Hello, 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 and welcome to Track 3. My name is Marcia Villalba. I will be running this track with you today. So we'll be here for many hours, but yeah, it's going to be fun. First, before starting out, some of the sessions have Q&A, so feel free to ask the questions in the chat. But there is also a Slack that you can find in cdk.dev, and there you will find the Slack where we have the different tracks, and you will be able to continue chatting. Also, there is a code of conduct. So if you see someone misbehaving or whatever, you can report them at report@cdk.dev. And then basically we can start because we have a very packed agenda that you can find in the CDK Day website, and you can see all the changes that are there. And yeah, let's get started. I will bring my guest that is to stream. Hello.
Hello.
Hello. How are you, Akos? Akos.
Doing well, thank you.
How are you doing?
Doing well, thanks.
Excited to present first presentation of the day. So you're going to talk about how to integration test systems built with AWS CDK. That's something that everybody should be interested in because integration tests are important and very few people know how to write them properly. So I will bring over your presentation and you can get started.
Cool, thank you. So let's get started with a question. I think this is kind of like the crux of the issues. When do you actually want to find issues with your code? Do you want to find them when you deploy, in a shared environment, or maybe even at development time? So who's ever deployed something and then was faced with an error message similar to this? So like, oh, access denied exception. You're not authorized to perform something in a certain operation, AWS operation. So yeah, we've all encountered these. And today we'll look at some of the strategies that you can use to discover these things much, much earlier than in a traditional testing pyramid. So my name is Akos. I am a engineer at Plane. Previously, I used to work at Babylon Health, and I specialize in backend systems. I've done a lot of things, but these days I'm super into AWS Serverless and TypeScript, and that's what today's talk will be about. About Plane.com briefly, we're a startup that's building a modern customer service platform for companies of the next decade. And yeah, like that's the context. And we chose to go full in on AWS and serverless because customer service is a domain where your traffic fluctuates a lot. But moving on to the main topic, which is testing. So testing cloud-native serverless solutions is a bit different than how we did in the past. In the past, we had application code kind of in a monolith, maybe packaged together, deployed. Infrastructure was typically centralized, at least at the companies I used to work at. We typically had minimal infrastructure as well, right? We had one database, one cache, maybe a handful of queues. And usually you build your system so you can actually run them locally, which means you use technologies like Docker and containerization. These days, everyone's kind of moving towards serverless and kind of managed solutions. Code is liability. We don't want to be writing non-value adding code, and in the end, we take all these managed services and integrate them together, and all this integration point is actually kind of becomes our application rather than just a containerized Docker image. So for an example, like if you need a delayed job system or a queuing system, in the past you might use one of these libraries in the various languages, or you might just use cron in Unix. But in 2022, I think most people would on AWS reach to one of these services like SQS, event bridge rules, and step functions. And you can't apply your previous testing practices to some of these new services, right? You can't effectively simulate all the features of these systems locally when they might have a lot of integration points with each other. So another example is this piece of code, which we're not going to go through the code, but this is something we have a plane where we have a webhook that is built as an API gateway REST integration directly to S3. So there's no Lambda involved. There's no code. All the logic is defined in our infrastructure. So here in this code, we're validating that the input is JSON, that it has a certain format, that there's certain properties in the JSON payload. It's not really feasible to unit test this, right? So taking a step back, why do we write unit tests, right? We want to have a high confidence that our application will work now and in the future, right? And we have the choice of like, do we want to write unit, integration, or possibly end-to-end tests? So unit tests, right, test the smallest unit of code. Integration tests is what we'll be focusing on today. I'm going to call integration tests that are testing multiple components working together to deliver a feature. And end-to-end tests is where you're kind of doing a bit of black box testing. And having good test boundaries is very important to have integration tests that are debuggable and easily understandable why they fail when they fail. So again, like white box and black box testing, it's up to you how you kind of want to do this. It's up to your domain and application. Our approach has been to go with lots of integration white box tests and maybe a handful of end-to-end black box tests. The benefit of lots of white box integration tests is that when they do fail, it's relatively easy to find out why they failed. And another thing that's very important to this is the integration test boundaries. So here's kind of two example scenarios of how we test a system at plane. First, we have like an API. We have a request response coming in. There might be some reads writes to a database, and then we would publish an event. So this would be one boundary that we'd publish. So we'd call this like an API integration test. We can have check the response formats, the request response, and that the events are published. We wouldn't go on and test any of the consumers because then we have kind of like a separate boundary of these integration tests where we do an event consumer integration test. So we'd kind of publish a similar event that we kind of asserted in the API integration tests and assert that maybe the right rows were updated in DynamoDB or that an event was published. And all this is white box. What we mean by that is that we were inspecting these internal implementation details, such as our event structure or maybe our database state. And these all help in making sure that your integration tests are actually debuggable when they fail. So let's go a bit more into our setup. So we have a CDK application. This deploys CloudFormation stacks, right? With the stacks then create all these resources. So we have a bit of integration test setup code that caches the stack outputs because we rely on these stack outputs to kind of then be able to figure out what resources need asserting on. And then finally, we run the integration tests. And these tests kind of just like test the whole parts of the system. And let's take a look at what one of these tests looks like. So here at the top, we have we start off with like a create new user. Here, the test we're looking at is just a simple creating a new workspace. Workspace in plain is where you do your customer support. So first we create a new user. Then this user makes a GraphQL request. This goes via API gateway. Then we assert the response. And finally, we assert that an event has been published on EventBridge. So what we did here, we tested everything from all of our API gateway configuration. We tested JWT authorization. We tested that the Lambda has access to the database, the Lambda can actually publish events, that everything that needed to be done by this feature is still working. And because of this test, we can be fairly confident that none of the changes in the future will regress on this very important feature, which is the ability to create a workspace, right? So looking at the continuous deployment of this solution. So we have each engineer has their own AWS account. They deploy their CDK application into their own AWS account. They write and run the integration tests against that deployed version. This essentially mimics production very closely. When the feature is complete, they open up a pull request, which again deploys a full copy of the application to another AWS account where the integration tests are run. After we've approved the pull request, it gets merged into our development environment, where after integration tests pass there for the third time, we automatically deploy to production. So with this setup, we kind of have this kind of high degree of confidence throughout our software development lifecycle that our features work as they should. So finally, let's touch on the developer experience, because I think writing integration tests needs to be very easy and great to do. And for this, we use Serverless Stack Framework. If you haven't heard about it or seen it, do check it out. It's a great open source library that's built on top of CDK. It has a few high-level constructs that just makes building applications very simple. It has automatic stage prefixing, which allows us to deploy our application in the same AWS account without resource names conflicting. And finally, it has live Lambda development, which I'll briefly show you how great it is. So live Lambda development works in a way where instead of deploying your Lambda code to AWS, it deploys a shim that proxies down via WebSockets the Lambda events to your local computer. So this allows us to essentially test your Lambda code using real AWS services rather than local emulations or mocks. And the important part to remember here is that your local computer is actually assuming the role of that Lambda. So all the permissions and everything is essentially very, very close to production. Not exactly, but very close. This results in a very quick feedback loop. So live demo, always great to do. So let's switch over to my IDE. And here we'll look at a very similar create workspace integration test. And in my terminal, I've already started up the SST live Lambda dev mode. So this deployed our stacks, and running this test right now, we'll see that, as I mentioned, we cache a lot of these CloudFormation stack outputs, and then the test will kick off. So again, just to reiterate, this makes an actual GraphQL request. It then does actually, in this test scenario, we then query that workspace is actually under your workspaces. And then finally, we assert that the event that is published is what we expect. So yes, we're using Aurora Serverless, and my database went to sleep for a bit, so we're just waiting for it to start up, and now we're good to go. And here in the terminal, we should see the requests being handled, and all of this is running on my local machine. Cool. So the test passed. Great. Let's actually make a quick change and show you the developer experience when you're developing your code. So opening up the mutation, I'll just make a quick change to our input schema. So rather than requiring public name, I'm going to say we're also going to require our first name. That's required. And here's where the magic is. So I'm going to hit save just as we're running in watch mode. Therefore, it's instantly going to kick off, and we'll see the request be handled. So hitting save, and the Lambda was rebuilt. And we can see the test fail. We got back an error that input validation, there was a validation error. So with this kind of very quick feedback loop, you can actually develop these integration tests with quite quickly. SST also has a console, which allows you to kind of inspect the logs very quickly. So here we can see that these were the Lambda logs. In the terminal, all your Lambda's requests show up. Here you can actually filter them down and see them much quicker. So that was it for the very short live demo. Go back. So finally, I'll finish up this talk with kind of 5 tips and tricks we use at Plane to make integration testing as smooth as possible. So first up, testing event bridge events. As I mentioned, we use event bridge quite a lot, and writing tests that assert them is quite critical to the functioning of our application. So what we do is we conditionally create a catch-all rule on each of our event buses, and then we have a tiny lambda that just listens to this rule and writes our events to a DynamoDB table. So we use for the partition key of the DynamoDB, we use our tenant ID, which is workspace ID. Therefore, we can easily get and assert on all the events that were ever published in that tenant or workspace. So the same can be done for if you're using SNS plus SQS. If you're only using SQS, it's a bit tricky. I personally haven't figured it out because SQS, your workers consume a single message, and you probably want an SNS before it to actually have that fan out mechanism. But with this, we can actually easily assert our tests, assert on our events, and we'll take a look at what this stack looks like, or what this CDK code looks like. So here we have an environment conditional at the top to say that we only want to deploy this in our dev and PR environments, not in production. We then create the DynamoDB for DynamoDB table for events. The rows items actually expire after a time, so we don't keep accumulating these events forever. Then we have the tiny lambda that writes to this table. And finally, for each bus, we hook up this catch-all rule. Next tip is around state management. So there's actually 2 sub-tips here. The first is to actually make creating state an application. So we built a tiny lambda that we call test data manager. This means that writing integration tests is a bit simpler because you just get to essentially ask for, I need a tenant in this state, please give it to me. And the test data manager contains that code that then quickly orchestrates our environment to put it in the right state. The other important thing it does is to queue the cleanup of the setup of that tenant. So this just makes sure that if the tests get aborted or something goes wrong, then the tenant, the workspace, will definitely be cleaned up eventually. This means that it's easier for environments to stay clean, to not have like tons of rows in your databases of like all these integration tests. And yeah, you can, with SQS, you can easily do this with a delay of up to 15 minutes. Our tests don't take anywhere near 15 minutes, so this works perfectly fine for us. And also the other tiny benefit is the tests run slightly quicker because they don't need to wait for a teardown step, but that can happen asynchronously in the background. So this is like what a seed command looks like for us, of like when you just need test data. So we kind of can give it multiple workspaces, and here we're asking for a dummy workspace with users in that workspace with certain issue types and 10 customers that have like random names and random emails. So my third tip is to speed up your deploys by sharing slow to deploy resources. So when we have pull requests, we do want to be able to quickly create these pull requests and merge them in. If we need to always deploy every single resource in our CDK application, that can take a bit of time. So we actually have certain resources that are in our infrastructure, what we call our infrastructure app, and the CDK apps depend on these shared resources. So you can use CDKs from ARN or from lookup to conditionally import these in PR stages, and then yeah, if it's not a PR stage, then just create the resource. So there's definitely a trade-off here, right? You're trading off correctness for a bit of speed, but I think that developer experience is definitely worth it. So my fourth tip is to run tests in parallel. So This is quite self-explanatory, but there's a bit of few things that you need to do, which is to make sure that your tests don't depend on any type of shared space. So for SaaS customers, you make sure that you need to create a new tenant for each test. For like B2C companies, you need to create a new customer for each test, and then run with as much parallelism as you can. Serverless, the nice thing on serverless, it will handle it. For us, the simplest was to just use Circle CI, extra large machines, and max workers of 40. And finally, my fifth tip is to discover flaky tests as soon as possible as you can. We use a simple strategy of just running these tests on schedule and sending notifications to Slack so we find these flaky tests quicker and can fix them. Unfortunately, flakiness with integration tests is hard to avoid. You will run into some kind of rate limits or random 500 failures. That's unfortunately one of the downsides of the solution. So that's it. Thanks for listening to my talk. And yeah, test in the cloud for very high confidence and deploys. And you can reach out to me on Twitter or on email if you have any questions.
Oh, again, thank you very much, Akos. I'm so bad at pronouncing names. So yeah, thank you. And if you have any questions, you can continue talking with Akos on the Slack channel, because now we need to move to our next presenter. So thank you. I'll remove you from stream now. And I'll remove the interpreter. And I will bring Alex here. This is so much clicking around. Hello, Alex. How are you doing?
Hi, Marcia. It's great to be here. Thank you.
Good. And we are ready to start. You're going to talk about methodology for building large applications using CDK. So I will bring your presentation and the stage is all yours. Have fun.
Thank you. So hi, everyone. I'm a solutions architect at AWS. And today I would like to talk to you about the methodology I created for building large applications using AWS CDK, like Marcia mentioned. And before diving into that, I want to make a few clarifications. So first of all, what does large really mean? So to me, large is an application that composed of multiple components, potentially managed by different teams, maybe front-end team, back-end team, chatbot team, payments team, and so on. And another thing is that I will not be talking about service discovery, i.e. how components talk to each other and communicate in between them in this session. So with that, I want to describe a few challenges that caused me to think about this, right? So one is operational excellence, which is essentially how a business can scale and deliver what is required to operate the business, right? There is then the reliability, how we can cause workloads to behave as described and correctly. And finally, delivery performance. So as the team becomes bigger, how we can still deliver fast and accurately to production. So as a cornerstone of this, I was relying on AWS well-architected framework, and I want to walk you through a few definitions here that I'm using in this presentation. So the first is component. A component is a code, configuration, and AWS resources that together deliver against the requirement. And a component is usually a unit of technical ownership, so a team probably owns it, and is decoupled from other components, for example, through an API, event-driven architecture, or whatnot. A workload describes how multiple components work together and communicate between them to deliver against the business requirement. And that is something that business and technology leaders usually care about. Finally, the architecture here, it describes how components work together in a workload. Is it, again, event-driven architecture, synchronous communication, and etc. And the technology portfolio is a bigger set of workloads that business needs to build to do what they need to do. Now, here I will be using a sample workload, let's say a trivia game. Now, why I decided to make it a workload? Because that's something that business leaders probably care about. How many gamers do we have? How many signups? what are the active monthly users, and so on, right, at this level. Now, on the technology level, we have all of those different components, like front end, back end, maybe a chatbot that people can use for real-time communication as they play, some operator dashboard that aggregates the metrics and alarms from all of those components to show some health metrics, and etc. And also a configuration as a separate component. For example, here I can manage my feature flags, turn them on, turn them off for the various capabilities that span components, right? That's why I put it here as a separate thing. Now, if I look a bit deeper, whoops, I think my presentation kind of went forward. So let me go back a little bit. Okay, and can I maybe share my screen instead? Just a second. Okay, so let me go back to the presentation here. So now looking at this workload, I want to address the challenges I mentioned before again. So the first is operational excellence. So what I can do over time, I can actually split the ownership on these components to different teams. Why? Because the way I design them is in a decoupled manner. So they don't depend on each other internals, but communicate through well-defined interfaces. And another thing that I want to discuss in more depth is how I would organize the Git repositories and my pipeline around those components. And I want to walk you through a few options and discuss the trade-offs through the lenses of reliability and delivery performance. So the first option that I'm showing here is having a single repository for a single component and a single pipeline. And to me, it provides me a high reliability because I have a small blast radius, right? So if I make an error in a single component, because they are strongly decoupled, it should not impact other components. And also the delivery performance is high because I don't need to coordinate any pushes that I make to production with the other components or with the owners of the other components. Another approach would be to have a single repository, but multiple components and still a single pipeline. So to me, that changes the game quite significantly. And again, high-low here is not like absolute values. Of course, there is a lot of gray area and spectrum in between, but I just use it for convenience here. So why the reliability becomes low? Because now the blast radius of changes increases significantly. So if I make a change in one component, and we can also do it from multiple teams, like work on that single repository, I can accidentally delete a file or change a file that impacts another component without really being aware of that. And it will take time in communication to understand what went wrong. And also my delivery performance becomes slower because I have a single pipeline. Yes, I can still deliver some things in parallel for those components, even in a single pipeline. But what happens if one of the components fails deployment? I'll probably want to stop the whole pipeline, understand what's going on, etc. And even if the other components operate fine, they will be still waiting for me to figure out what happens with these one or two components that fail. Another option is to have multiple pipelines for those multiple components in a single repository. That actually still has reliability low from my perspective because of the reason I described in the previous slide, but my delivery performance becomes high because now I can really decouple the delivery of those multiple components to production. And even if one pipeline fails, I can still deliver to the other pipelines, right? And finally, I can do multiple repositories that together comprise a single component and deliver that through a single pipeline. Now here, the reliability is still high because my blast radius is still that of a single component, like in the first option, but my delivery performance can be low here because I now need to have some mental model of how all of those different repositories and whatever they contain come together to provide the functionality of that single component. And if there is an issue, I need to potentially work across multiple Git repositories to debug that and coordinate my debugging environment and whatnot. So hopefully, sorry, I'm summarizing all of these 4 options. And as you can see in the table, the first one allows for both high reliability and high delivery performance. And maybe that explains why the picture I showed you initially has a single Git repository and a pipeline attached to each component. Now, again, there are different business realities, different practices, and what I showed you is a trade-off analysis, right? Eventually, some of them might be more suitable, some of them less, but that's what I'm using here in this example down the line. Now, if I pick inside a single component, let's say backend, what I'll find there in this example are a few logical units, let's say an API, database, and monitoring. Now, I need a way to describe a deployment model of those logical units. I can deploy them as a single stack, maybe 2 separate stacks, or 3 if I feel fancy, right? So I need this functionality, and also need a place for my tool chain, things that define the pipeline, how I do pull request validation, and potentially other things, right? And to me, the component and the CDK composition model map really well to each other, because what are we doing in the CDK application? We take all of those constructs that to me represent logical units, and we compose them into a higher order application. And here, if I want to do a deployment of those constructs, I will use a stack and a stage if you are one of those that use CDK pipelines construct. And I will also deploy the toolchain in a separate stack. Now, why? Because I might change my toolchain down the line. Maybe I'll switch from CDK pipelines to Jenkins, GitHub Actions, GitLab, and whatnot. But I definitely don't want that change to impact my environments, pre-prod, prod, etc. So that's why I keep those separate. Now, if I look inside one of those constructs, which is an API, what I like to look at is having the infrastructure and runtime together inside that API. So when I build an API functionality, ideally I would like just to use infrastructure services. I would like just configure them. I don't know, maybe configure as an API gateway that will run, write and read from Amazon DynamoDB without any custom logic, or maybe use other services, right, to implement my business logic, maybe some workflow, some fraud detection capabilities, and so on. But in some cases, those services maybe don't have exactly what I need, and I need to extend them a bit. And that's, to me, where the custom logic is coming into place, and it usually happens at some runtime. It can be deployed in AWS Lambda, Amazon EC2 instances, containers, or whatnot. But CDK really allows me to put those together, because separately they don't really make sense, right? But only together they comprise a business functionality to me. Now, if I look how this structure of that component is manifested in file view, that's something that would be something like that. I would have an API folder with an infrastructure module or maybe a package, and then I would have a runtime folder. In this case, you can see I have a Lambda function module, and I know that this is a runtime for a Lambda function in the infrastructure. And then I have a database, for example, which only has infrastructure because there is no custom logic I need to add to this, for example, right? So that's kind of a simple way to look at this. And now I want to do some walkthrough around the deployment model and the toolchain. So I'll switch to my browser here. And you can see that I have all of those folders. It's an example project I use to test my ideas, right? And I have the deployment.py file. So if I go to the deployment file, you can see that I import the classes for those logical units. And user management backend component, it inherits from stage class because I use CDK pipelines. And here I define a stateful stack that contains the database logical unit, but I also define a separate stack called stateless that includes the API and the monitoring logical units. So this is an example of how I do deployment model for that specific component. And I also have my tool chain defined here. And in this case, the tool chain contains two logical units, one that describes my continuous deployment process, and another one describes how I do pull request validation. So hopefully, walking you through this now makes better sense of why the CDK application composition model maps so nicely in my mind to a component as described by the well-architected framework. And I want to wrap up and go over and hopefully show that this methodology can help you improve your operational excellence by having the ability to easily split the various domains between teams, improve the reliability, for example, by picking a single repository for a single component in a single pipeline, and through that also improve your delivery performance. Now, a few resources I want to leave you with are AWS well-architected framework that has all of those definitions that I mentioned, but also all of the operational security and other pillars that can guide you on building scalable applications. Automating safe hands-off deployment article by Claire Ligori that describes how Amazon does safe deployments. And finally, CDK best practices. So I used all of these, and I think they play really nice together. And with that, I would like to thank you for listening and see if we have any questions to answer, maybe.
I was mute. Typical thing. Thank you, Alex, for your time. And we can take one question before we need to go to the next presentation. So the first question that comes in the chat, I will take it for Alex, if it's relevant to this talk. If you have more questions, Alex will be in the Slack channel, I imagine. So in Track Free, you can reach out to him and ask him questions. There is conversation going from the previous talk, so you can keep chatting there. They're just thanking you, but so somebody's saying thanks, Alex. So it seems that there is no more questions, but very interesting, your presentation. And I think one question a lot of people will ask, if you can share the links. So maybe you can drop them in the Slack channel, because that's the typical question. What is the GitHub repo? I didn't have time to see it. So please drop them in the Slack channel so we can share them around, because I didn't have time to capture them.
Definitely. They also have the QR codes that people can later scan on video, but I also drop them in the Slack channel as well.
Yes. I don't know. It seems that there is no more questions. So stay tuned in the Slack just in case. But I will do the switch now of presenters so we don't need to run around.
Thank you very much.
So thank you very much, Alex. And let's switch now to let's switch the interpreter. We will switch Kira to Wes. You have been seeing our interpreters coming in and out. We have these two amazing persons helping out today. So thank you very much. And we have Andy now that is going to do the next talk.
Hello, everyone.
Hello, Andy. How are you doing?
I'm very well. I've been praying to the demo gods.
Good. We have a couple of candles here light up today for all the demos that are going to happen in CDK Day, because it's we're risking it out.
Oh, yes. Live deployment coming up.
Yes, so you're going to talk about testing constructs in the cloud. I love this track. It's so much about testing and deployments are two topics I love, and I have so many of those talks already, and I'm so excited because I love this. So I will bring your presentation and let you go.
Okay, thank you very much.
You will have Q&A, so we have time for you. We don't need to rush. So there is time for Q&A live with Andy. So ask your questions in the chat. I will collect them and then ask them to him. So I will get out from here.
Thank you. Okay. Welcome to my talk on testing constructs in the cloud, which is going to be code-based. So without further ado, let's see the construct we're going to be testing. And as all CD advocates know, you can build your application using zipped constructs which encapsulate multiple resources. In this demo, we're going to test a construct which is made up of a Lambda function, which subscribes to an SNS topic, which receives events which contain arrays of numbers. The Lambda function sums up the numbers, and if the total is positive, it publishes to one SNS topic. Otherwise, it publishes to a different one. So our challenge is, how do we test this? But first, let's have a look at the actual construct. So the beauty of constructs is you can define an interface, both an input and an output. And the input follows the props pattern. In this case, we've got our input topic, which we'll be subscribing to. Our outputs are two SNS topics, one for positive sums, one for negative sums. We have our function, which using the Node.js construct, we can very succinctly define, and we pass in the topic ARNs. And then for the function, we can add a subscription to the input topic, and then we make sure we grant our function the ability to publish to the various topics. Looking at the function itself, this is quite straightforward. Take its SNS event, we write it out just so we can see what's going on, and then for each one of the events, we pull out the numbers event, we sum up the event total, and depending on the event total, we pick one of the topics and publish out. So that's great. But as other people have touched on so far today, the challenge is, how do we test this as a whole? Because we can't read an SNS topic, and we can't locally test that we've got the right permissions. And so what the key idea here is, we can use the power of CDK and the fact that you can take one construct and reuse it in different contexts and actually deploy it in the context of an integration test stack. So this is a stack which is solely for the purpose of exercising this construct. So let's have a look at our test stack. And so far, this is pretty much a normal test stack, apart from the fact it's subclassing a component, an integration test stack, from an NPM package which I created, which allows us to do various things, such as we're able to tag resources for easy location. And the only thing that the integration test stack needs above is an ID, which is just a simple string, and this will be used when it's tagging resources and locating them. So we have our stack, and we need to do our system under test. So we define our construct, and I'll just add the import to make everything happy. And as you can see, it's demanding its input topic. So what we're going to do is, as part of the integration test stack, we're going to deploy a topic which is solely for the purpose of driving our tests. And we are going to tag this resource so that we can easily locate it without need for locating ARNs. So to do that, we define our topic, and the first part is just standard CDK. The second then starts to use a feature of the integration test stack, which allows us to specify an ID which it will tag the topic with, and we'll see how that's used later. So now we have a topic to drive our construct, but the question is, how do we observe that the events get published to the correct topic? And the solution is to create and to subscribe to the individual topics and write out the results to a DynamoDB table, which is purely, again, for the purposes of testing. So we will create Lambda functions and pass in an ID to them. And then these will write out events, the event they receive with their ID to an observations DynamoDB table, which will be tagged. And then we can read those. So this is where we can take advantage of the integration test stack. And again, the power of CDK in that by defining this array, one or more entries in this array, the integration test stack will generate a function. And because we have at least one observer, it will generate this table and tag it for us. This is really showing the power of, code infrastructure as real code. So once we've got our functions which will observe the topics, we just need to subscribe them to them. And we do this by using the test functions object, which is part of the integration test stack. Use our ID to get it. And then once we have the function, we just use the add subscription method. So now we have our whole test infrastructure. We need to deploy it to the cloud, which I will do now. So this is, as I said, a live deployment. And I'm using the hot swap flag here. And the hot swap, we all know, can never be used in production. But our integration test stack is always non-production. So we're quite comfortable using it. We don't have to worry about the warning. So we'll set those deploying, and then we'll have a look at how we're going to actually test this. So to test it, we're going to use another part of the NPM package, the CDK Cloud Test Kit that I've written. And this integration test client is used by the unit tests and works in conjunction with the integration test stack. In particular, it uses the tags that have been put on the resources, these test resources, to easily locate them or locate them in a deterministic fashion. So let's write our test. So we'll just do some imports just to keep it happy. And we're going to write a test which checks that if we put a positive, an array which sums up to be a positive number, that it gets routed correctly. So first of all, in our range step, we create our test event. Nothing particularly special there. Then we want to act. And what we want to do is publish that event to our topic. And this raises the question of how do you locate the topic? We've not got any CDK outputs. And this is where the tagging approach comes in. So we create this test client, which is the integration test client, and we pass in the stack ID, which we defined as part of our CDK stack. We then initialize this test client. And what this initialization step does is it queries your developer account using the SDK, and you can query tags. So it's looking for tags for this particular stack. And then once it's got its database of, or basically lookup table of all the test resources, you can use this method to get a test topic to publish on. And behind the scenes, it's used the tag to get the ARN, which was used at deployment time, but this hides this away completely from the test. So we now have published our event, but we've got the challenge of, well, we publish here, it may go through here, sometime later it'll come through here, sometime later it'll go down there. It's not like a classic unit test where you make a call, see what your result is. So what we have to do instead of just an arrange act assert, we have another step, which is await. And in the await, for the await step, the test client has a poll test method, which will, for every 2 seconds in this case, for up to 12 seconds, it will check, run the until function to see if it returns true. What it's also doing is it's returning an array of test observations. So it's reading this table every 2 seconds. So in this case, we're just looking for anything that gets put into this table. So once it's either timed out or something derived from that table, we can assert things. So we assert that it hasn't timed out. We will then assert on the observations. So we filter the observer ID is just the ID that we pass to the subscriber. So here we can filter the observations into 2 arrays, and then we can check that the observations are as we expect. We can go further and we can look at the actual content of it. So we're checking that the event has gone through the whole process exactly as we expect, hasn't been transformed in any way. So hopefully we did deploy, that is a relief. We will run our test and see if the demo gods are smiling on us. Now this does take a little while. It's always going to be slower than a in-memory unit test, because as we start this up, it just query the account for the resources. This is something that at least I do know. So what I've failed to do is I failed the observations table here needs to be initialized before each test. And making this call clears down the table. So this avoids one test interfering with another. So we'll rerun the test and pray once more. I hope Marcia's got another candle on. This does mean that in this case, within one stack, have to be run in, can't be run in parallel. And as we wait, we actually found that it's timed out. So what we'll do is we will have a look using the serverless console, which I thank Marcia for introducing me to. We shall have a look at our stack. Stop shouting on the and if we have a look at this, we had our service. So we can actually see here behind the scenes it created the Dynamo table plus these 2 functions, which are the subscribers. But if we have a look here at our You can see we logged out the event, but here we can see, hopefully it brings it across, we've got some issue with the ARN when we're publishing our event. So we go back to our function, and some of the more observant viewers may have noted that there was an error. So we spotted what we did wrong, and we will run. And this is where the hot swap flag really comes in useful, because in this case we've only updated the Lambda function code, and hopefully it should bundle itself up and push it up without doing a full redeployment. And indeed it did. It's good. So we go back to our test and we run this again. Hopefully this time it works. So again, we're pushing our event in, letting our observer pick it up, push it into our test. And there we go. We can see that our test is passing. And we can, so to reiterate what we've done there, we've actually, in a few minutes, created a test stack, deployed our test resources, and pushed our event through, and actually asserted that it went through the right route and that it came through okay. And what we can actually do is we can actually go further than having passive observers here. So the Cloud Test Kit allows you to actually specify a mock response script, if you will. And these become not just observers, they become actors. So, for example, if you're trying to test retry or dead letter queues, you can externalize the functions being called by the construct and then give those constructs a script. So in this case, I'm saying to this credit rating function, can you error the maximum number of retries and then send a payload? So this opens up some interesting testing potential. You can have a step function and externalize the individual functions and use that to push it through different routes. So the possibilities are probably endless. Yeah, so I think that sums up everything there. I blog at AWS Hashnode, part of the Hashnode team, as I also do at temperatimecool.com. And on there, I did a series which was about this approach of integration testing. So, and the Cloud Test Kit would be great if that's useful for anyone. I use it myself. I'm on LinkedIn and Twitter, and that's my talk.
I always need to remember to unmute myself. So thank you very much, Andy. I will leave the links in the screen for a while because these are really cool. Going definitely to check your CDK Cloud Test Kit because it looks very cool and it sounds like it solves a lot of my problems. Somebody's asking, Werner is, but not our boss, I hope. Werner is asking if the links can be posted in Slack. Can you do that,
Yep.
Andy?
Yes, I'll post the link to the GitHub repo, which has all the code on there as well.
Yes, because it's easier to copy and paste, and I totally agree with that. And I also saw in the CDK track 3 that people are loving the serverless console, and I'm super excited about it because since I discovered it, I cannot stop using it. So it was really cool to show it there. Yes, and if you have any questions, we have like 10 minutes before we need to jump to the next talk. So please ask them in the chat. But I would like to know like how you come with this approach of building the cloud test kit, because this is something I imagine maybe it's a recurrent problem that you had, or.
I think I was getting my head around how to build serverless applications, and the one thing, the whole testing aspect of it was the one that was troubling me. It's great to do event-driven applications, but the asynchronous nature of it, and how from a classic unit testing point of view, you can't take the same approach, the act, as it's sit, arrange, act, assert. So there had to be another step in there, this await. So you're trying to think of, well, I want to test this, but it's more you have to observe the side effect of your application. So what do you need to do that? So that was the idea of having observers. So you create observers, but without CDK, you would have to write some CloudFormation or a SAM template, but when I was seeing how you could construct applications out of constructs themselves, become like subsystems. So you can deploy a subsystem with its own test harness. And the ability to just be able to spin up a database for your results, which you can clear down whenever you want. So I think having CDK enabled just gave the idea of being able to spin up a test harness for your construct.
Yeah, that's super cool. And one question, how you delete all these resources, because you create like all this infrastructure around the construct. Is that a part of your test at the end? Like you do the before initializing everything? Do you do also a delete at the end after the test?
Well, you can just pull down the stack, of course, the stack with CDK destroy afterwards. So you would control that outside of the actual unit test. So to prepare for the unit test, you deploy, run the unit tests, and then destroy the stack down. And if you're developing locally, as we saw there, I tested it and without leaving VS Code, which is, didn't go into the console. I didn't see any ARNs at all. I didn't have to worry about locating things. So this is something that, doing really is it's as well as potentially being part of a CI/CD pipeline.
Yeah, that's what I was thinking. Like, because usually if you have it like looping around, maybe you are creating a lot of resources and then you want to destroy them. But that's what I was thinking of.
Yes, you could possibly combine multiple one test stack for multiple constructs. That's a possibility. So that may help there in terms of manageability and.
But that's the cool thing of serverless, that if you don't use it, you don't pay for it. So you can basically launch as much infrastructure as you want, and then if it's idle, well, it's just there.
Yes.
Then you can just remove it whenever you feel like removing it, or you reach the hard level. You have 100 Dynamo tables. You cannot create anymore. Like, damn. Yeah, but it was really, really nice. And I like to see you using tagging, because that's like, I think in the serverless world, nobody tags anything.
Yeah. Yes. Well, yeah, because the tagging is quite powerful, really, because that was the question I was trying to think of. Is I don't want to worry about how to get hold of a topic. I just want to have a topic. For example, you can do the same with is it SQS or event bridge. You just want to say, get me the topic, publish it. That's it.
Yeah. And your tag it's an ID, so it's something very specific. So it's not like.
Yes, it's deterministic. So you don't, of course, you don't want to specify the name of the resource. We all know that's really bad. So yes, it's a deterministic way of identifying the resource. Yeah,
I think that's super cool way of using tagging, and I hope people in the audience give a look now. Somebody let's share it in the Slack, the CDK Cloud Test Kit. So imagine that people are getting inspired by this, because it was so cool to see. And as a developer, this resonates so much, because this is the way that I'm used to building unit tests. Like, it's not weird things, just the mocha with like the different steps. Well, there's the weight there, but still it's very like comprehensible. So I'm really excited to see this more in practice. And it seems that people don't have questions. You leave them speechless. Yeah. Have you applied this in different, and what kind of constructs do you have applied this in? Only event driven or in other kind of scenarios?
Only really in event driven. Where you've got an API, a synchronous API, then you might as well test that as you would do any other way. But yeah, so it's really not to say that you couldn't take this approach with that, but you don't need the await step in that, or it depends if you're looking really for. I know side effect programming is bad, but event driven is you look for the side effects of what you've done, whether it be in a dead letter queue or whether it be in the right place.
If there is no side effects, nothing is happening.
Well, yeah, exactly.
Sending events and hello.
Yeah, it's interesting if you're trying to test for nothing happening, because sometimes if you're trying to test for a rule that, and you're deliberately putting an event in that shouldn't match that rule, you've got no option than to wait for the timeout. It's quite, that's the only way I could think of testing for the absence of a side effect.
Yeah, and one other question. I'm full of questions always, and as the audience doesn't have questions, I get to ask them. This is something you do in your staging environment. You don't do this in production, or do you do this?
That's right. Yes. So yes, this is as I said about using the hot swap flag.
Yeah.
These are non-production stacks. These are purely thinking about how to exercise that construct. And I think in the series I did, I did an example of an application where it starts off as just a large group of, or not that large, but reasonable sized group of Lambda functions, Dynamo tables, and looking at how you can decompose that down into subsystems, which you can then encapsulate as constructs. And you're looking at the boundaries. And then you take each one of those constructs and deploy that into its own test stack. And then I think the first talk today on this channel was about looking at those boundaries and testing those subsystems, and this is where this fits in nicely with that.
We have one question, and I'm excited because this will be the last question, and you can continue chatting with Andy in the Slack channel. Matt is asking, this kind of testing involves deep knowledge of the resources being deployed. Do you see an evolution where we have clear, higher level abstractions for async testing?
I think it's moving towards that. I think we're seeing. I think there's a number of serverless testing frameworks which are starting to meet the need of these more modern applications, the event-driven applications. I think in the first talk today, there were some interesting ones about publishing to EventBridge or reading from EventBridge. I think it's natural because there's going to be more of these applications and people want to be thoroughly testing them. Yeah, so I think so.
Cool. And with that, we have to say bye-bye to Andy, but I'm pretty sure he will be in the Slack channel, happy to answer more questions. So go to cdk.dev, find the Slack channel and ask all your questions. There's many people already chatting there. And with that, I will say thank you very much and let's move on. I will switch my interpreters now. So bye-bye, Wes, for now. And let's bring Kiera. So, and also I will bring Marco, that is our next presenter today. How are you doing, Marco?
Hi, everyone. I'm great. You?
I'm good. This is an exciting day. We have a lot of candles around for the demo gods. So if you have a demo, I got you covered. It's been great.
Luckily, no.
Okay. Do you have your presentation somewhere that I can put in the screen, or you are going to just show us your face today?
No, I will share my screen.
Awesome. So you're going to talk about CDK8 versus Helm, a TrueLayer study. I don't know what is anything of that because I'm not a Kubernetes person. So luckily, I don't need to talk about that. So the stage is yours and have a great talk.
Nice. Thanks a lot. So this talk shows the pros and cons of creating a common Kubernetes chart with CDKs and Helm, based on a real case study at TrueLayer. I'm Marco. I'm a software engineer in the engineering ops team at TrueLayer, and I'm based in Milan, and these are my contacts in case you have any questions after the talk. So let's go. The agenda for today is the following. Why creating a common chart in the first place? Then two tools that we evaluated to use at TrueLayer for this purpose, and then a comparison between the two. So I hope that at the end of the talk, you have an understanding of the trade-offs between Helm and CDKs when it comes to creating a Kubernetes chart at your company. So why creating a common chart in the first place? Before introducing a common chart at TrueLayer, the process of creating a new app was the following. First, you identify an application that it's really similar to the one that you are going to build. Then you shamelessly copy-paste all its manifests, and then you just tweak the values that you need to change, such as the name, the namespace, and so on. This, as you can imagine, is very painful, and there are some issues. For example, there is no golden standard, and this means that it's hard to establish conventions inside the company. So, for example, if I'm a new joiner, where do I look if I want to create a new app? There is no golden example. Also, you end up having the same YAML boilerplate spread everywhere. And the amount of YAML required to create a new application is simply too much. So let's say that we created this new app, right? Then the problem is also that we need to keep it up to date. And the requirements of an application at TrueLayer change very often. For example, the platform team might ask you to add pod destruction budget, to read secrets from Vault, to add pod topology spread constraints. These are all great initiatives that increase the security and the reliability of our applications, but they require time and effort to be ported in all our apps. So let's take Vault as an example. You need to add all this YAML in all your developments and even more in order to read secrets from Vault. So maybe you do it for the first time, then you do it again for another deployment, again and again. Yeah, it's painful. Also, let's say that you copy-pasted this YAML in all your manifests, right? Then you need to maintain it. Let's say that, for example, the platform team tomorrow decides that we don't want this annotation anymore. Then all developers need to delete this line, raise a PR, get it approved, merge, deploy again the service. So it's really painful. So what we decided to do at TrueLayer is to delete some of the complexity from the manifests that developers need to manage and extract it into a common chart. This common chart is managed by the platform team, which has more experience and more knowledge to manage all this complexity. And so this common chart is a way to centralize conventions and best practices just in one place. And so you remove duplicate code, and the services are updated way more easily. So in the end, the devs just set the values of their applications, and then they are merged into the chart. So for example, the Vault use case that we saw before might become like this. So the dev just explains the intent of what it needs to do, and then the platform teams converts this intent into the full YAML. Another great example, I think, it's network policies. So for example, here I'm enabling RabbitMQ egress and Prometheus ingress. These are like, all these network policies are giant block of YAML that are spread everywhere with hard-coded IP ports. This is not ideal. Instead, with a common chart, you can just express what you need to do, and then the chart takes care of expanding those flags into full YAML. So I hope I convinced you that maybe you need a common chart in your application, in your organization. Now let's review Helm, which is the first tool that we will see that lets us create a common chart. So Helm is an open source project, and it's the standard package manager for Kubernetes manifests. It allows to create common templates, which are called charts, and distribute them. This is how an Helm chart looks like. You have templates, which are just files that explain the structure of each Kubernetes manifest. For example, here we are seeing a template for the config map, and then the developers needs to fill the placeholder that are in these templates. For example, here the data. Then we have the chart.yaml, which just declares your chart with the name and the version. Then we have the values.yaml file, which probably is the most important file in a chart. And here, for example, this file contains the default values of the chart. For example, in our chart, we don't create a config map by default, but instead we create a service account by default. The devs need to override the values of this file that don't satisfy their needs. Also, we have the values schema JSON, which is optional, but it's really recommended because it defines the structure of the values.yaml. So when the devs don't respect this structure, they at least get an error, so they know about it. And so the platform team of your organization can put the chart at disposition of the devs. The devs just fills the values of this chart. So here, for example, the data are injected in the config map, and Helm merges the chart and the values to create a manifest that you can then apply to Kubernetes. And you can do this by running kubectl apply, or even by using Helm install to install the chart in the cluster. So to let Helm do the work. So great, now we're going to see CDKtf. CDKtf is an open source tool that allows you to define Kubernetes applications using familiar programming languages. And as Helm, it synthesizes your values, let's say, your definitions into standard Kubernetes manifests. So first, we're going to see how to create an app with CDKs without using an external chart. In fact, CDKs allow you to define Kubernetes manifest without using YAML at all. So for example, here we are using, we want to create a service and the deployment, and we reuse the built-in types that CDKs provide. So we fill these TypeScript objects in this case, but there are also Python, Go, and other programming languages supported. And then CDKs simply generates the manifest for you. So great. Now, what if we want to extract a chart from our manifest? So it's a simple application. So I mean, it's a normal programming language. So you just identify the values that you want to extract, and you can extract them into variables of extract. For example, I created the property.
Hi everybody,
extract.
Thanks for tuning in.
And so this struct can be filled by the developers. So this is the struct that we created before. This serves as an interface for the developers. And in fact, the developers can fill the values of this interface. So maybe instead of numbers and strings, you can have things like network policies and vault, as we seen before. And so the devs can fill this. So CDK combines the chart and the values and creates a manifest that you can apply to Kubernetes. So the flow is very similar to Helm. Great. So we saw CDKs. Now we're going to compare these two tools. So the first difference is that CDKs is Kubernetes aware. We saw before that we have the kube service type, we have the kube deployment type. Here, for example, I'm using the kube config map type to create a config map, and CDKs simply creates the YAML without me having to specify the version and the kind of the object. And this is because CDKs has a configuration file called cdks.yaml, which allows you to specify the Kubernetes version of your cluster. So when you bump the version, CDKs will update the kind and the API versions accordingly. So this is very handy. Instead, Helm is not Kubernetes aware. So unfortunately, you need to specify the API version, the kind, everything. And yeah, so in this case, the platform team needs to even create the config map manifest because nothing is really provided by default from Helm. And the devs needs to fill this config map. Another downside of Helm is that you need to take care of specifying how many white spaces to put before every YAML block. And instead, in CDKs, you just filling structs, so JavaScript structs, Java structs, whatever. And then CDKs knows how many spaces need to put in the YAML. CDKs uses familiar programming languages, as we saw. This means that you can leverage the tools you already use and love every day. For example, you can use autocomplete from the IDE. You can catch errors early directly in your IDE. Instead, Helm uses a custom template language, which I think it's fine for basic use cases, but as soon as you want to do more complicated stuff, it becomes a little bit trickier. Also, you cannot see the errors in the IDE. You just need to run the command L template to see the errors. So yeah, the developer experience I feel is better with CDKs. And you can have autocomplete while filling the values.yaml file, but only if you fill the values.schema.json. So another cool feature that I like about CDKs is that it allows to compose different charts. What do I mean with this? So until now, we have the devs that fill the values of a chart that is maintained by the platform team. And this defines a very clear separation of responsibilities between devs and the platform team. However, there are many services in a company, and some of them are really similar with each other. For example, we might have a lot of HTTPS servers inside our company. And it doesn't matter if these services are owned by the same team or by different teams. The important thing that I want to highlight is that the structure of the manifests of these services will be the same, but each service will have its own values. So what we can do is that we can consider the chart that we created at the beginning as the base chart, and the platform team can extract the structure of the manifest of the HTTPS servers into a new chart, for example, HTTPS chart, which is built on top of the base one. So in this case, the developers fill the HTTPS values, which will have less redundancy, because let's say the HTTPS complexity is handled in the HTTPS chart. And it can also happen that the HTTPS chart is built by the developers directly, because in the end, charts in CDKs are just TypeScript libraries, Python libraries. So developers are free to build on top of them. And so developers can create charts specific to their services, for example. And this allows to reduce the barrier between the platform team and the developers team. So the devs can self-serve. And Helm, unfortunately, doesn't allow to compose charts in this way. In Helm, you can add resources to an existing chart, but you can't customize the existing template. So you can't alter the JSON schema, the existing JSON schema. So to wrap up a little bit, let's see the different, like a summary of the two approaches, pros and cons. So CDK's pros is that, as we saw, it has a better development experience, and in general, you use programming languages, so it is more powerful. You can read files, you can read environment variables, you can do whatever you want, basically. You can reuse external libraries too. With Helm, instead, we have the pros that it's a widely adopted tool, and this is because the vast majority of the projects provide Helm charts if you want to deploy them in your Kubernetes cluster. So at least every platform team, I think, that should know Helm if you're using Kubernetes. Also, there is a less complexity in the sense that Helm uses a template language, not a general purpose one. So since the language is less powerful, you can consume external charts more easily in the sense that it's easy to inspect them, audit them, and even understand what they are doing. And for the same reason, Helm charts tend to look more similar between each other with respect to CDKs, which uses general purpose languages. So really developers have a lot of room for inventing ways to create Kubernetes manifests. So from what I saw, in general, if you come from the dev side of the DevOps culture, maybe you're already familiar with TypeScript and other programming languages, and you don't want to learn yet another language. So maybe you will prefer CDKs. Instead, if you come from the ops side of DevOps, you might prefer Helm, because maybe you don't know TypeScript or all these other programming languages. So maybe you prefer the Helm approach because it's just simpler. So maybe now you're asking, okay, but which tool did you pick? And it was a really, really hard decision, but in the end we picked Helm. And that's because the platform team was already using it. The developers team some developers were already using it. We already built some existing internal tools compatible only with Helm. And our developers mainly use C# and Rust, which are two languages that are not supported by CDKs. So in the end, we decided to not introduce yet another tool inside our organization. However, I mean, we saw that. First of all, I want to emphasize again that this was a really hard decision to take, and yeah, CDK has a lot of advantages. So really do your research and pick the tool that is best for your use case, because they're both great tools. Thanks a lot. That was all.
Oh, hey. Thank you, Marco. This was really interesting if I knew something about Kubernetes, but I imagine our audience was super excited about it. And are you taking questions in the Slack channel after this? Or can they find you there?
Absolutely,
Because
yes.
We don't have time for questions, and I'm pretty sure people will have more to say and things to ask. So if you have any questions, go to cdk.dev, and there you will find a link to connect to Slack. And in Track Free, you will find Marco and everybody that's watching. And with that, I will thank you again, and I will move to the next talk. So thank you, Marco.
Thank you. Bye.
Bye. So for the next talk, we have Jannik, and he will be talking about integration testing in serverless architectures using CDK provider framework. So I will add him to stream now.
Engineer at Hashnode, a serverless and front-end enthusiast, and I will be talking about integration testing in serverless architectures using the CDK provider framework. Let me switch over to my presentation. So what I'm going to talk about is the following. I'm going to start with the basics on why I think integration testing is especially important in serverless architectures, and then some theoretical stuff on CloudFormation custom resources and also about the CDK provider framework. And in the end, there will be a demo where I will be showing this to you. So from my side, I think there should be two key takeaways. The first is why integration testing is especially important in serverless architectures. And the second one is on how you can utilize the CDK provider framework and use it for either testing or also other cases. So first of all, this is maybe an architecture that is familiar to you. It's not about the special application right here, but the main point is there are several pieces in this architecture, a lot of moving parts interacting with each other, which is typical for serverless and also event-driven architecture. So the point is, as you can see here, there are like two lambdas, and these are probably the two that you will be testing using something like unit tests. But in the end, as you can see, it's only a small piece of the puzzle, right? There are a lot more moving pieces, probably, which makes sense. You won't test like in a 3 bucket with unit tests, but all the pieces have to connect to each other. They have to work together for a working application. So this is the testing pyramid, which is probably familiar to most of you. As you can see here, the biggest part in the testing pyramid are the unit tests, but somehow there's like a disconnection between the application on the one side, where you gonna unit test like only the small piece, and the testing pyramid where unit tests are the biggest part. So don't take my word for it. Here's a quick quote from the Serverless Architectures on AWS book, which is awesome, by the way. You should check it out. But the gist of it is unit tests do not provide much confidence for serverless architectures. Integration tests get more important the more integration and moving pieces there are. So in the end, like all the arrows here. So this is why I think something like the testing honeycomb, where integration tests are the main part, is especially important in serverless architectures. So you can see here there are a lot of pieces, a lot of arrows, things that have to work with each other. So for integration testing, there are different ways how to approach that. Usually you would spin up like a temporary environment, run your tests against it, spin it down, which works. It takes quite some time because, yeah, you have to spin up a whole application and an environment. I'm going to show you a different approach today using the CDK provider framework to integrate the tests directly into your deployment of your main stage, so to say. Okay, then let's get to the CloudFormation resource basics. And yeah, so the CloudFormation custom resource are extension points to the CloudFormation provisioning engine. Resources that are not yet supported by CloudFormation can be created that way, or you can basically do whatever you want in this custom resource provider, the Lambda you see on the right. How it works is the CloudFormation provisioning engine will send events for creation, the update and delete to the custom resource provider Lambda, which you have to provide. And then you can deal with it and do whatever you want. In our case, we'll be doing tests. So then you'll send back a CloudFormation response to CloudFormation, which is either a success. In this case, the deployment will go on and continue, or a failure. In that case, there will be a rollback, which is important because that's one of the main benefits of the approach I'm going to show you. So you don't have to deal with rolling back an environment manually. This is built in CloudFormation and it's like done for you. And one quick note, you could also like use SNS instead of Lambda here, but I think for now I go with Lambda. And now to the CDK provider framework. As you see here, there's like an additional Lambda in the middle, which is by the CDK provider framework itself. So again, you receive the events from CloudFormation. The CDK provider framework will pass it on to the custom resource provider, which is created by you. And then you can do something without it, and either you return something or undefined, it doesn't really matter, which will be interpreted by the CDK provider framework as a success event, or you throw an error on your Lambda, and then in that case it's a failure event. So the piece in the middle does some things for you. And as you can see here, this is from the README of the provider framework. You only have to focus on the highlighted parts here. So the CDK provider framework is a mini framework, making it easier to implement custom resources. So there are different reasons why you might want to do it. I'll highlight it on the bottom part here, the two main points in my opinion. So it protects against stuck deployments. So if you use only the custom resources and you will have an error or whatever, you don't return a response from your custom resource provider. In that case, the deployment will be stuck for several hours, which is really bad, as you can imagine. And the other point is, with the CDK provider framework, you can also deal with asynchronous execution, even above the 50-minute mark. And yeah, that's also a big benefit in my point. All the other things are like work that is done for you. It saves you time, but yeah, it's also quite nice, but not the main point in my opinion. But enough talk, let's see it in action, and let me switch over to VS Code now. So here we are again in VS Code now. I've created a small demo app, a note-taking app, which just provides the basic API to do CRUD app operations, but without the update part for nodes. And here we are in the node stack, which is the only stack in the app. And so it consists of an API and an API test stack. First of all, let's have a look at the API right here. So the API is nothing special. It's just a DynamoDB table for the nodes and a Lambda here, and providing some access, and a REST API with some path and methods added to them. I've added a small monitoring info route here just to showcase the rollback in the end. So there's no special meaning in this. So I think we can skip over this part. Also, the handler itself is nothing special, just a quick glance at it. So this is the handler for the API. Here's the monitoring thing I just mentioned. We'll update the version here and then redeploy it in a bit. And yeah, so also this part, there's nothing special. I went with the lambda-lith approach here, just for simplicity. There's no real meaning in that one. So here you can see the method handlers for handling post, get, and delete, handle post, handle get, and also the handle delete. I will also skip over these. You can have a look at them in the repository. In the end, there will be a link to the repository and also written out so that you can type it. But that's not the main part I'd like to show you. But if we get back to the API test stack, which is where the actual testing will happen, and if we have a look at this one, here we have a Lambda again. So this is a basic, a simple construct that I've created, which is just a Node.js function so that we can use TypeScript and use ESBuild under the hood to bundle everything. And it goes along with its own log group so that we can set a retention and remove a policy. So that's only a side note here. And so this is the resource provider, the custom resource provider. So the Lambda on the very right in the image, which I've shown you. And we will have a look into that in a bit. Here's the provider, so the actual CDK provider framework, which in the end deploys the Lambda, which was shown on the left side in the image. And also, as I've mentioned, you can use the provider framework for asynchronous testing or asynchronous creation of custom resources, I should say, as well, which is quite handy. That's not in scope of this talk, but it's good to know, I think. And down here, we have the actual custom resource, and we connect everything together by providing a service token here, the service token from the test provider, and the test provider links to the custom resource provider or the on-event handler right here. So all these three pieces are connected. There is one thing here, it's the timestamp property. The name doesn't really matter, but so custom resources don't get updated or recreated or whatever if there's no change for them. So if there's no need to update them because the properties don't change, then the code in the end of our handler will not be executed. And since we want to always execute our tests, this is why we added a timestamp here, which is basically different every time. So let's have a quick look into our Lambda code before we deploy. Here we can see this is the CloudFormation custom resource handler. And as we see here, we get this one, this gets called every time there's a create, update, or delete event. And in case of a delete event, we don't really want to execute our tests. We want to execute them when we first deploy, so on the create, and every subsequent time, so on all updates of the custom resource. So this is why there's nothing happening in the delete request. But after then, we run our run test function down here. And as I mentioned, if this Lambda throws an error, then that will be treated as a failure event and sent back to CloudFormation. And in that case, the rollback will be happen. Down here, our run tests. So basic operations. We first of all create a node. We then get the node, compare them if they are identical, and then in the end we delete the node. So the actual implementation of these isn't really important, but as you can see here, there's no real test framework as such. You have to provide the code in an imperative way yourself, so that might be one downside, and it's not suitable for all use cases, I'd say. So yeah, I think we don't have to get into details here. As mentioned, you can look it up yourself, but now let us first of all, if I can type correctly, build this thing and then deploy it. And I'll speed up the deployment and we'll see each other after it's done. Okay, here we are again. The deployment was successful. Let's jump into the AWS console to verify that everything is in the correct state and that the tests were actually executed. As you can see here, there is a node stack and the nested stack for the tests. And if we have a look at the lambdas, we'll see 4 lambdas. One is our actual API implementation, our test handler, which we provided. This one is just to set a custom log retention. And as you can see by this description here, this one is the lambda, which is provided by the provider framework. So let's have a quick look into the CloudWatch log for them. And yes, as we can see here, this is the payload which is passed on to the on-event handler. We'll also see that log output in the custom resource provider lambda itself. And yeah, it's a create event in this case. It's then executing our test handler lambda here with that payload. It sends a status code 200, there was no error thrown, and this is the CloudFormation response. As you can see here, this is created by the CDK provider framework. We had to do nothing here, it just implies it by not throwing an error that everything went successful, and that is why also the whole deployment went through. If we have a quick look at the log group of our test handler, and then we'll see, okay, we'll test this API right here, we created a node, we retrieved it, and we deleted it. So all the 3 tests that we've written passed. Okay, and now verify that we catch any errors. In order to do that, I'll change the read-write permission here to maybe just a grant read, which will then cause the test to fail because we can't create a node in the first place. And also let's verify that there will be a rollback by updating the version number right here. And now we again build the thing and redeploy it. Again, it takes some time and I'll see you in a bit. Okay, here I am again. Now we can see that this time the deployment was not successful. There was actually an error and a rollback happened and some error code here in our test handler. Let's first verify that there was no update of the API. You can do that by grabbing the path right here, and I'm using Thunder Client, which is basically a built-in Postman as a plugin for VS Code. And then we do an info, and it's in version 1, so it's not updated. Let's check the logs again. if we go back to the log groups and have a look at the provider framework log group, there are additional events now. There is now an update event, and this time the provider framework sent a failed status response to CloudFormation. That is why the rollback was triggered. And after that, we can see here that there was another rollback to redeploy the old version, so to say, and there is now 200, so that one worked, and that is the one that's deployed now. And also, just to verify it, in our test handler, we again executed the test, or at least we tried to, but this time there's no successfully created node in this execution right here, because we revoked the write permission, and that is why it failed. So basically, we now executed the tests as part of our deployment, and the rollback was done for us. So if you remember, if you create an additional separate environment with the tests there and rollback, then yeah, you have to handle all of that yourself. But in this case, the provider framework did that for us. And as you can imagine, there's a lot of things you can do with the provider framework. Also, you don't have to write the test like I did it here. You could also just do some smoke tests to do a basic ping or whatever you want. But the gist of it is that you can really do a lot of cool stuff with the provider framework. For example, integration testing. And I hope that this was something that you could take away from this presentation. And by that, we're coming to an end. Thank you everybody for attending. You can see here the code and also the slides are available in this repository. Here's my GitHub handle, and I would be happy to connect with you and have some great discussions about serverless, front end, whatever tech. So see you there.
So that was Jannik, and he told me that he's in the Slack in the track free. You can find him if you don't know how to get to Slack, cdk.dev. There you will find the link for the Slack channel. And in the track free channel, you will find Jannik and ask him all the questions you have. And now we will move on to the next talk. And this talk is a hard name for me to pronounce, so I'm so sorry if I said incorrectly. Vojtěch or something like that. I'm so sorry. I don't know how to pronounce it. He will be talking about hands-on monitoring with CDK constructs. So I will bring that to the screen right now.
Hey folks, this is Vojtěch here. It's my pleasure today to talk about CDK monitoring constructs. So it's a library that we created internally at Amazon, but we actually made it available as open source recently. So I'll just give you a little introduction, what it is, what you can do with it. So for following the talk, you don't really need much experience. Just need some basic knowledge about AWS, CDK, TypeScript. You should be able to know how to create and deploy CDK app, and that's that. So yeah, not much. So let's start with what the library actually does. So it simplifies monitoring. And how? By simplifies here, I mean it reduces effort, it reduces code and time needed to set up monitoring for your AWS app. And we do that by having high-level methods and declarative definition of alarms. And of course, you can structure your dashboards a little bit, so you can add also some headers, custom text, custom metrics, of course. So yeah, just to make your dashboards a little bit nicer. So what's the history of the library, how it came to be? Of course, it can be accounted for to laziness. I think it's a good thing for developers to be a bit lazy, because when you do a lot of boring work, it leads to ideas how to reduce that work, right? Because if you are not lazy, you just do everything. So in our case, what happened in late 2020, we were developing about 5 new apps using CDK at once. And I think that was a great thing because we noticed a lot of patterns and commonalities. So we were defining like, disk space alarm 5 times, CPU alarm 5 times, and all these things. And we just noticed that this is repeating a lot. And also it repeats in other teams as well at Amazon. Because we have a lot of these like best practices, which metrics we should monitor, latency, errors, resource usages, I/O, and all these things. So we extracted the code first to a team library, but shortly afterwards, we decided to make it generic, so any team at Amazon can use it, and we published the package internally. So that was our humble beginnings, and people started to use it, and it was a really big surprise. We achieved thousands of internal usages, and I think what's most important, we also got some contributions, and I would really like to thank to all the contributors that contributed to the library. It's about 50 people, I think, at this point. So really appreciate, folks. That's really nice, and I'm looking forward to see even more. And hopefully, some of you watching this video might actually contribute to the library later. So that would be super nice, and go for it. The next logical step was to think even bigger and think about publishing the library externally as open source. So as you can imagine, taking internal library and making it open source is a little bit tricky for a big corporate such as Amazon. So yeah, there were some processes involved, some approvals. Yeah, but we made it eventually. So yeah, we are here today, and the library is available. So yeah, you can already use it. The tricky part was actually splitting the internal from public. Yeah, as you might know, Amazon uses internal ticketing systems, and also we have proprietary things like severity, and there may be different concepts of severities and all these things, out there. So of course we had to make it more generic, so you can specify your own severities and our own mechanisms for ticketing. But yeah, it was ingrained into the library, so you had to really do a lot of refactoring there. So we get it clean and generic enough for everyone to use. And finally, early 2022, we published the public part as open source to GitHub. Cool. So what's the general idea of the library? So our opinion is that metrics, alarms, and dashboards are really just one thing, like different views of the same thing. So the important thing is the intent. So what do you want to do? You want to monitor a certain thing. You want to know whether a certain thing goes above a certain range. And that's the metric and the threshold. And alarm and dashboard is just visualizing that. So what we want to prevent is people putting one value to an alarm and the second value to the threshold, and third thing into the annotation, fourth thing in, description, whatever. We just want to have one single value that drives all of these, and so if you change it, everything gets changed automatically. The second principle is the library is opinionated, which means that we took some decisions for you, which we hope they are good decisions, but of course you might not be happy with all of them. But what's happening here? So for every AWS resource, you typically have like tens of metrics, right? And some of the metrics are more useful than others because most probably many teams will be using and monitoring CPU usage rather than something a little bit more obscure. So yeah, there are some metrics that are just like very important and you want to have like first-class support for them. And the goal of this is that you can make the common things, the best practices and everything easier with less effort, because everything is like prepared for you to make this, to make it this easy. Of course we try to keep the library open so you can extend it and you can add your own things into it, like your own widgets, your own modules, your own metrics. So if you're not happy with the decisions we took, then you can add your own. You can extend it. And so how do you use it? Like, what is the idea of the usage? So first you create the main monitoring facade. That's the master object, that enables access to the rest. You declare what resources are to be monitored. You declare alarms, and the library takes care of the rest. It behaves just as any other CDK construct, so it does everything in the constructor and generates alarms, dashboards, places widgets on the dashboards for you. Yeah, that's what the library does. So what kind of dashboard it creates? There are 3 types. Just very quickly. So the default dashboard contains all the widgets, like all the level of detail that you defined. The second is a summary dashboard, which is something like 50% of the default dashboard. It only contains the essential widgets. And why did we do that? So for example, you might have multiple services and you have a, I don't know, wiki page or something, and you want to include multiple of these services into a single view, and you just want to quickly review health of your system that might be consisting of multiple services. You just want to evaluate that quickly. So you want to save time, you want to save attention given to each of the services. So you want to reduce the number of noise and number of widgets that might not be that important for this kind of view. And then we have dashboard with alarms only, and that's useful maybe for when something happens, you can just take a look at this dashboard and see what alarms are on, what alarms are off, to see how bad it actually is. So that's the dashboard's created. And yeah, we're getting close to seeing some code in action. So let's see. So we have a simple CDK app with an SQS queue, and we want to have a dashboard with queue size, and we want to alarm when the queue size gets over 100. So we are going to implement this first with Rodi CDK, okay, and then we are going to take the same use case and implement it with our library, just to see the comparison of what you need to do, okay? So let's go. So first, you create a CDK app. You can use CDK init, I think. Yeah, CDK init, and yeah, you create a stack, you add the SQS queue, and that's it. So that you have a queue. The second step is to create the metric and alarm. So luckily you can use these helper methods already, which are in CDK, that allow you to create the metric out of the resource directly with all the proper dimensions and names. You don't need to remember it. And of course, if you have the metric, you can call create alarm on top of this metric, which is another helper function. So yeah, you can use these helper functions, and you have metric and an alarm. So the third step is to create the dashboard, the widget, and add the widget on the dashboard. Yeah, so that's it, and that's what we get. We have this beautiful dashboard with beautiful widget, and yeah, it still needs some attention to make it nicer, but yeah, that's what we get for a few lines of code, not bad. So let's take a look at the steps we have to do. So create metric, create alarm on that metric, create widget with that metric and alarm annotation, create dashboard, place widget on the dashboard, and still it's not super beautiful, so we need to make it a little bit nicer by adjusting the sizes, adjusting the metric labels, units, yeah, something like that. So let's try the library, shall we? So first step is to add the library to your project. So this is for npm because we are going to use TypeScript, but the library uses JSII, the build system that is the same is used for AWS SDK. So the library is available also for Python, Java, C#, and in the future also it will be available for Go, and it's open source at GitHub, so you can take a look. So once you have the library in your project, you create this master object, which I mentioned before, monitoring facade. So yeah, it's a little bit chatty, but yeah, we are working on it, so you need to define less properties actually, but yeah, it's not so bad. So you need to specify defaults, like how to name your dashboards, how to name your alarms, and that's pretty much it, and what kind of dashboards you want to be created. Oh yeah, so that's nothing like super complex here. It's just a few properties you can tweak to suit the names to your needs. So once you have this created, it's only getting easier, so no worries. So yeah, this is how we monitor the queue size. So just call monitor SQS queue, you give it the queue you want to monitor, and you declare the alarm, max size alarm, and we can call it like warning, and whenever the queue size reaches 100, you will get the warning ticket or SNS notification and as an action. Okay, so that's easier, right? And the good thing is that you can extend this by multiple alarms with different identifiers and different thresholds. And of course, there's like multiple types of alarms, so you can alarm or whatever. And this is what you get. So yeah, basically like a default layout of the widgets related to queue. So yeah, you get a header with a nice link. You can click and go directly to the queue. You can monitor message count, message age, message size, whatever. And always if you add an alarm to something, it will draw this annotation for you. So yeah, even if you have multiple ones, it will be shown in the same widget. Yeah, and that's it. So you can create all the alarms you need, and all of them will be rendered nicely in the dashboard. And of course, this is just a random collection of screenshots of our dashboards we have internally. Yeah, so you can see, for example, the top one here is the Fargate service with some utilization metrics, Elastic Cache cluster. Yeah, but we can do anything. Most of the AWS services are supported. You know, DynamoDB, SQSQ, SNS, step functions, instances. Yeah, I don't know from the top of my head, but it's a lot. And you can also, you know, ask for supporting something that's not supported yet by cutting us a ticket or issue in the GitHub. Great, so now we can explore a little bit of code. All right, so now we are in my IDE. I have created a project by running CDK init, and I've added the package to the dependencies, as you can see here. And I have also created 2 tables and 1 queue. So that's the simple resources we are going to work with. We also have the facade here ready to go. So we can try monitoring these resources now. So what are we going to do? We are going to try with creating some structure. So let's say we want to have a large header saying storage and the second header saying messaging. These will be visible on the dashboard. So under the storage, we are going to add DynamoDB table monitoring. So we are going to call these methods monitor DynamoDB table, and we will pass them to tables like this in props. Yeah, so we have the user table, and this is the event table. Okay, so we have these tables, and the remaining thing is this messaging section. So we're going to use the monitor SQSQ method, and it also needs to have the queue passed. Okay, so that's pretty much the idea. So as you can see, the interface is fluent, so you can just chain the method calls. And as of now, there is no monitoring, it's just widgets. So when you run this code, when you deploy it, you will have a dashboard, and on the dashboard you will have first a large header, you will have widgets for first DynamoDB table, then you will have widgets for the second DynamoDB table, then another large header, and widgets for SQSQ. No alarms whatsoever. So if you want to add alarms, you need to do 2 things. So first you need to define your action or default action. So the one that comes out of the box is SNS alarm action strategy, which means that whenever an alarm gets triggered, it will send you an SNS message, SNS event to be more correct. Okay, so I don't have that SNS, so I will not use that as of now, but you can do it your way. Sometimes there are some tools which are integrated using SNS queues, like your ticketing system, so that's exactly the place you're going to use it. Alright, so now we have the monitoring, and let's add some alarms. So for example, we want to add alarms whenever DynamoDB tables are throttled. So to do that, we need to add a rethrottled events count alarm. So we will use this property, and to this property we will define an alarm called warning, which will specify max throttled events to 0. And we can do the same for writing. It's the same idea, just change read to write. And we can also do the same for the second table. Yeah, here. Okay, so this warning, what it is exactly? So this is like a name or identifier for that specific alarms, because you can have multiple alarms on the same metric and you can call them differently, so their names are not clashing. I can show you how this works on SQSQ. So let's say we want to monitor on a max size, so I can use this add queue max size alarm, and I can have multiple levels of sensitivity. So I can have warning, for example, with max message count of 10. Then I can have critical with max message count of 100, and I can have like meltdown of max message count of 1000. So these are basically 3 different alarms with different thresholds, different names. There will be 3 different alarms also in CloudWatch, but they will all use the same metric, the queue size. Does it make sense? Alright, so that's pretty much it. So when you deploy this, you will get a dashboard as before, but this time it will have some annotations and alarms created, and whenever these events occur, the alarms would get triggered. Okay, so that's it. Now we can take a look at our GitHub. So let's do that. If you want to find it, just Google for CDK monitoring constructs and you should find it. Otherwise, you can also go to GitHub to CDK labs/CDK monitoring constructs with hyphens. So here you can find a README with installation guide for different languages, list of features, some quick start, and yeah, some explanations about how custom metrics and monitoring scope works, and of course a guide to contribute. Sure, and if you have any idea or you would like to contribute, we are super happy to welcome you here on this GitHub page. You can submit an issue for feature request or a bug, and also if you feel like it, you can also fork the repository and make your own pull request. So yeah, there's still a ton of features you would like to have, and we are open to suggestions how to make this library even better. So please, if you have some extra time and you are excited about this area, we are more than happy to approve your pull request, put some comments, some feedback, and yeah, thank you in advance. Alright, that was it. Thank you very much for your attention. Google for CDK monitoring constructs if you are interested in the library. I hope you enjoyed and learned something new. Have a super nice day, and I'm signing out. So take care.
So that was Vojtěch, and I hope you enjoyed that talk. If you have questions, we have a conversation going on in the track number 3 in the Slack channel. You want to get to the Slack channel, cdk.dev. There you will find the link on how to register, and you will find track number 3, where all the discussion is going on with the speakers and questions are being asked. Now we will go to another talk. This time is from Daniel. He will be talking about hybrid CDKtf constructs. I'm horrible at spelling. You already know that. And we will jump into that talk right now.
Hi everyone, I'm Daniel Schmidt. I work at HashiCorp on the Terraform CDK team. And today I'd like to talk to you about hybrid constructs. With hybrid constructs, I mean constructs that can also ship Terraform modules that you can publish on the Terraform registry and use with your already pre-existing Terraform configuration you might have. So let's first talk about what constructs are. This, for example, is from open source code from someone who built the GitLab runner as a CDKtf construct. CDKtf constructs, or in general constructs, are classes that extend from the construct base class, and they are used to encapsulate functionality that you can ship and distribute as binaries to your favorite registry according to the language you want to consumers to be able to use it. So to PyPy, to Maven, to NPM, to nugget, and so on. And these constructs are really the foundational building blocks of working with CDKtf and all the other CDKs. So the great thing about constructs, from my point of view, is you can interact with them in a imperative way. So you can call functions on them, and yeah, basically dynamically do things with them. And you can pass a construct to another construct and have like dynamic behavior, or like not dynamic behavior, but you can make the behavior depend on each other and define really complex things that would be really tedious to define otherwise in very elegant ways. And another thing that's so great about them is they're super easy to extend. You can just extend the base class, and you can override any method in them that might be used to generate some internal configuration. So it's really easy to make them your own and to adjust them to the exact use cases and problems you might be having. So for example, in this construct, there's a private method that defines like a Docker volumes list and kind of builds a string by iterating through the Docker volumes passed. And if you, for whatever reason, needed to adjust that, for example, to make like the volumes read only or something, then you can do that. It's just extending the base class, overriding this method, and the construct you get out of that has a different functionality and like is adjusted to what you need from it. And if you work with Terraform, you use Terraform modules most likely. It's the way of defining a construct basically in Terraform. So you define a module, again, that encapsulates some functionality. In this case, it's a VPC, like the AWS VPC module. And you basically can configure it through all these options passed, but that's basically it. There's no dynamic things. Modules can't interact with other modules. You can't do like imperative calls on them. It's very limited to that regard. Yeah. And the question is, why would you want to ship both even? Let's talk about that for a second. So constructs, obviously you want to ship because you want to distribute them around teams using CDKtf. And for modules, the same for users who use Terraform. And if you're a big enough org or like an organization that already uses Terraform, you might have some teams that are still in the Terraform world or want to stay in the Terraform world. And you have teams who want to be in the CDKtf world and use CDKtf to provision their infrastructure. And if you want to cater to both, you need to ship both. So whenever you come up with a new thing you want to ship, instead of writing it 2 times, it makes sense to just have one source. And in the end, the source can be both, right? If you're more comfortable with writing like Terraform modules, you can write Terraform modules and redistribute them as CDKtf constructs. And if you're more comfortable with like CDKtf, then you can go that way around and define Terraform modules out of your CDKtf code. We're going to explore both options in this talk, and we're going to start with the latter, so from constructs to Terraform modules. And for both of these, we have projen templates that you can use. And yeah, projen is in the end a construct-based solution to build your project infrastructure, so all the files you need to have a fully working and functioning project. They can be defined in projen, and there are great projects already to build upon that handle all the publishing to the different registries. And we have a extended version here that also does all the tooling you would need for Terraform. So that is really a few manual steps you have to do to get your project into Terraform registry as well. And we also added some nice helpers to build some configuration for you that help you publish to GitHub packages and to the open source registries and so on, that take care of all these like nitty-gritty details that you would normally need to take care of. So let's dive into it. This is the Proton CDKtf hybrid construct template. You can use it to initialize such a project that can distribute the construct both to normal registries and to Terraform. So you initialize it with npx proton new from this project and then hybrid module. And let's dive into what it actually generates. So let's take a look here at the Proton RC. This is what configures the project. We decided here to publish to GitHub packages just because it's super convenient. There's some restriction on the naming for GitHub packages, so we take care of that as well in this configuration. But for other registries, you can have a different name for the repository and the package that's actually published. And for the repository, you need to start it with Terraform. Otherwise, you can't put it in the Terraform registry. There's a hard requirement there. So I can specify here my author and my address and so on. As a dev package, I have the Proton template I mentioned, and then I decided to be on the 10.4 version of CDKtf, and I want to have constructs enabled and like construct examples enabled and put them into examples constructs, and I have the Terraform examples enabled, and I put them here into examples Terraform. You can put in also some provider configuration, and you can specify that you want to plan the Terraform examples. I don't do this here because I don't have credentials in my repository here, but you could do that if yours has some credentials. And yeah, as a peer dependency, we also specify that we need the pre-built AWS provider here. And yeah, that's basically the configuration. Now let's take a look at the construct itself, just to get a base understanding. So we built this construct here that exposes a S3 bucket class and a function to notify a Lambda function about an event in this S3 bucket. So if an item is put, post, or deleted, we will get some notification, and we will set up the event type and so on accordingly. And it's based off a Terraform module. We generate that module here with the CDK JSON, and as part of the build pipeline is built and published with the rest here. Now let's take a look at how we define the Terraform modules. We have this tf modules file here, and it's basically instantiating a class that extends from the Terraform module stack, which is a Terraform stack replacement, especially for modules. Yeah, what it basically does under the hood is it strips out stuff that Terraform doesn't understand in the module context, that is needed only for the execution context. And we have some helpers here to define module variables in a convenient way that are not like suffixed or anything. And in this case here, we define like that as a variable, we want to have the bucket name, and we have to have the Lambda function name. And then we create our S3 bucket construct here with the bucket name, and we put in a data resource here to fetch the Lambda function with the Lambda function name and put that into the notify Lambda function call to generate this kind of module. This is not as, like in general, as I mentioned, the Terraform modules are not as easy to override and so on. So you would like to normally have some more cases here, but for demonstration purposes, I only have one. The important part is here we put this into our app and synthesize this as a dedicated stack with a certain name that's descriptive. And then we have a correlational markdown file here that describes how to use that. And examples for all of these files are generated if you start the template new. So it's rather easy to pick up and to extend to what you need it to be. And then as part of the build process, we built an examples folder here. For the constructs example, we have a stack here, and we initiate the S3 bucket and Lambda function and so on. We show some use cases, and as part of the test, it's built every time, and we verify that you can synthesize it and that your configuration in this example still works. And in the Terraform part, we also generate this configuration here, and we can put in our provider configuration here. And this Terraform example is also validated and eventually even planned if you want to do that. So we can check if it's actually working or not. And the example is up to date. And then let's see what actually is then exported as a module. So we have here under the modules folder a dedicated folder for each of the modules. These are like submodules in general, if you want to stick to the Terraform way of calling those. And then we have a README file, and here's a bunch of configuration documentation that we also generate from the Terraform configuration we have. Like this one is synthesized from the stack we have, and based on the README and the metadata from this, we have a more complete documentation here as well. Let's take a look how the publishing is done. So on push of master, we have this release pipeline here, and what it does is it runs the normal release process for modules. It runs the test and so on, checks that no change has been happening and so on. And as part of the release, it tags the version of the, like the new version of the project, and then pushes something to GitHub releases and to the internal registry, to npm, Maven, and Nugget. And if you configure it with GitHub packages, you can see the packages here that are being generated, and you can use them according to the documentation here. And since a tag is being generated for each of the versions, we can access that tag in the Terraform registry, because Terraform will pick that up and publish a new version on the registry. Publish a new module on the registry, you have to visit registry.terraform.io, go to the publish button and select module. Now the registry will fetch all the repositories in your GitHub username. If you're not logged in, you will be asked to log in, and I can specify here my Terraform CDK hybrid module, agree to the terms of use, and publish the module. And now you can see here our module has no root configuration because we only specify submodules. This is how the hyperconstructs work. Because we have multiple stacks we can initialize, we just use the submodules. So here's the submodule we created, and we can copy our configuration here and use it straight away. And you can see also the documentation that you saw previously. Let's talk about the other way around. So if you already have a couple of Terraform modules that you want to repackage as helpful constructs, you can do so by using the Terraform module projen template. Let's take a look at how that would look like in practice. So this is a package I freshly generated, and the projen TS looks like this. We want to write something that repackages the EKS module that we provide from the Terraform AWS modules, and we also include 2 submodules here. So when you synthesize the projen template, then you get the CDKtf JSON generated for you, which has the same modules that we defined earlier. And it generates this modules folder here that we check in because we want to distribute it. And in the index.js, we export everything from Terraform modules, which is also auto-generated, similar to the CDKtf JSON controlled by projen, and it exports every single module, so you don't have to think about re-exporting too much, besides leaving this auto-generated line here in. So in this example, we also wanted to make it a bit more interesting and use some functions, imperative functions on the construct that we want to expose. So we have this EKS cluster class here that we extend from construct, and in that we initiate a EKS construct. This EKS construct is a binding that CDKtf generates based on the Terraform module, and you can feed it some options that we also take here as options. And you can call then add self-managed group on this this function and on this class, and you get to put in the node group name and some optional options. That's a hard one. And yeah, we use the cluster name and VPC ID that we already used in the main module here, so you don't have to duplicate that, and have a nice interface. To summarize, you can use the projen CDKtf hybrid module to generate you a new project structure for the construct that you want to publish or the Terraform module that you want to publish, and either repackage your existing Terraform modules as constructs and make them nicely usable within the CDKtf context, or deploy the CDKtf constructs that you write as Terraform modules for your Terraform audience. The project template takes care of all the testing, all the tooling and the build process, everything that you need, and also publishing all this to all the registries and to Terraform registry. And yeah, I hope you enjoyed the talk and took something away from it and try it out. If you have any questions around Terraform CDK or this project in specific, go to the CDK Slack channel and go to the Terraform CDK channel in there, and yeah, drop us a message and let us know. Take care, folks. Bye.
So that was Daniel, and now we will have a short break until 10 past your hour, 1:10 Pacific time, whatever 10 your time. So you can go, recharge, and come back, and we will start with Wes. So I see you then. So we are back from our short break, and now we have another talk. We have Wes Eklund talking about CDK strategies for large enterprises. I will bring Wes to the stream. Hello, how are you?
Hi there, how's it going?
Are you good? Having a good day?
Yeah, I'm having a great day. I'm having a great day.
So
Before I start,
yes.
I'd love to say that, wow, 30 sessions, over 30 sessions, 3 tracks. Just give it up for the organizing team for today. I can't imagine how hard that's been. So yeah, thank you.
It's been awesome. We got so many submissions and it was so hard to pick. So we took them almost everybody. Let's make tracks. Yes. So I think this is great. And I have the best track, I have to say. So if you're watching here from the early of the day, just give me a high five in the chat because we have a long way. And I just got another talk at the end of my track when I thought I was finishing early. But I'll stop talking because this is your time. So I will open your slides and we can get started.
All right.
Good luck.
Thank you so much. Hi, everyone. My name is Wes Eklund. I'm a software engineer at AWS. And today I'm going to be talking about CDK strategies for large enterprises. And a quick note, I may pause. There are planes that come overhead, so I will protect you from the noise and pause every now and then. That was perfect timing because we just had one. All right, so about us. So I'm on a team at AWS called Customer Engineering. We accelerate AWS's largest customers. We develop and deliver production-ready code and infrastructure. And it's really rewarding because not only can we build for customers to help with their digital transformations, but we also help with their cultural transformations. A little bit about me. I've been at AWS Customer Engineering for about 1.5 years now. It's really rewarding, and I love what I do. Previous to that, I worked at a med tech startup, Lifelines Neuro. They make EEG machines and cloud software to support it. So if you imagine EEG as if MRIs are pictures of the brain, EEG is brainwaves over time. So a lot of interesting work there. And then also I've worked at a men's suit and tuxedo startup. A lot of interesting problems there with fitting someone using AI and ML. And some of my interests outside of coding, I love orienteering, which if you're not familiar, it's essentially cross-country, but you have to find the finish line with a map and a compass. And then I also have a fixer-upper that I work on. And being in Kentucky, I also love good whiskey. So, little disclaimer. So I am not on the official AWS CDK team or spokesperson. I'm just an engineer, and our team, we use CDK day in and day out to help customers solve their problems. So hopefully our experiences and some of the things we've learned can help you and some of the problems that you're solving for customers. So I want to just from the get-go call out, if you learn nothing else from what we talk about today, know that not all adoptions are easy. Being customer obsessed means truly understanding the requirements and the underlying why for your organization. And given that not all adoptions are easy, I would really challenge you to dive deep and consider all that CDK has to offer and things that you can make on your own. With some custom designs, you can leverage the power of CDK to meet any requirement. And I'm super bullish on CDK long term. So let's talk about what we'll cover. So first, I'll talk about the need the customer had and what they wanted us to build. The environment that they sit in as a large enterprise and some of the controls that they have. The challenges that we faced, meeting the customer where we were at and wanting to leverage CDK. And then ultimately what we agreed upon was a good design for their needs. And then some of the takeaways that we have from those designs. All right, so let's talk about the need. So our customer needed a platform built that all of their other engineering teams could leverage, and this would help accelerate their digital transformation. They wanted it built for scale, reducibility, security, and auditability. And they wanted to find the right balance between their existing internal compliance controls, which they were aware could slow down development, and how can we find something unique that we could stay compliant and also move quickly. So during this time of our discovery and working one-on-one with the customer, we wanted to figure out the environment, the AWS environment that we were in. And some of the things that they came to us with were they had a really clear and distinct culture around segregation of duties. So this concept of you have your application builders, they control their source code, and they build products. And then operators, they manage the infrastructure that the applications sit on. And so that had some interesting challenges with provisioning and permissions and security. Another thing we heard was resource instances are tightly controlled. So IAM users, roles, policies are managed, able to be audited, and various tools that could automatically grant permissions wouldn't be an option. Another one was everything that's built in the organization considers auditors as a first-class citizen. So naming, organization of resources, documentation, all of that became extremely important during our development. And then again, I've mentioned before, knowing all of these things help us move fast without compromising on our controls was something we heard a lot. So as our team, kind of ingesting the environment and thinking through how can we meet the customer where they were at and leverage CDK to reduce the amount of cloud formation, to have reproducibility, to have to shift security left. There were some challenges with using CDK out of the box. So one of them was the accounts that were provisioned for us to use did not have administration permissions. If you try to do the CDK flow by default, it will ask you for an admin role. CDK pipelines, really powerful tool. For our use case, wouldn't be able to scale because we needed ways to separate out builder responsibilities versus operator responsibilities. And then we knew that we couldn't guarantee that all constructs we would leverage wouldn't try to grant policies on our behalf. And so thinking through these challenges, we brainstormed as a team and came up with these tenets that our CDK solution needed to have. So we needed to make sure that our roles and policies would be controlled, immutable, and static. This was a key kind of mental model difference between using CDK by default and the way our customer wanted to leverage CDK. So, depending on the constructs that you use, they could create their own dynamic roles and policies, and we needed to make sure that we didn't include those. Another one was ensure that across all of our infrastructure, resources would have user-friendly names and have a schema that was consistent across all of our infrastructure. And then third, we needed multiple pipelines and to separate out the various pieces of our platform by builder and operator roles. So for instance, networking and security layers would be owned and operated by the operators, and application layers like Lambda AppSync would be owned and managed by builders. So I'm going to break this down in a few more slides because there's a lot here. But here's kind of a high-level breakdown of what was critical to helping us solve the segregation of duties. So you see here we have various layers that help us deploy various resources. And so you see in our custom bootstrap, you have a very distinct owner of permissions, so lead platform engineers, and this custom bootstrap layer would have various static roles and permissions for child code pipelines. Core infrastructure, you could consider that security and networking based resources. Those would get run on a code pipeline that the custom bootstrap would create. Various security resources, and then also permissions for child services. So you're starting to see a pattern here where each layer kind of creates pipelines and dependencies for child layers. And then I'll just go over application infrastructure. You're starting to see the developers, the builders that own these. So Cognito, user groups or user pools, SQS, S3 buckets, and then separating out app stacks. So having a separate pipeline or repo for AppSync, Lambda, step functions, incorporating CloudWatch, observability into those. And then that way, this adheres to segregation of duties across the platform. So key pieces here I want to call out. There was a lot on that last page. I had some icons there for code pipeline, code build. So each pipeline, each layer has its own code pipeline, and in code build, that's where we would actually run the synth CDK CloudFormation code to actually stand up that infrastructure. As I said before, each layer provides the dependent resources for the next layer, and parameter store is used heavily to reference these resources across the layers. So I'll go through these bit by bit. As I said, custom bootstrap, this would be CloudFormation templates that the lead platform engineer would own and manage. It creates initial code pipeline and permissions for core infrastructure and ensures all roles are immutable. Next, core infrastructure, you can see each layer is a different job role, and so that there's clear governance and segregation of duties. I do have just to illustrate the example here, I have a little bit of code where I create a new role. We make sure we cannot make policy updates. We add the flag add grants to resources. And then each one of these resources, we ensure that the ARNs are sent to parameter store. In application infrastructure, again, these are by the architects and the developers. They create resources that can be shared across various, quote, app stacks, Cognito user pools, SQS queues, S3 buckets. And here, I'm just showing another quick example of creating a resource, putting the ARN in parameter store for child layers to leverage. And so application stacks, so these could be your APIs, your step functions, various odd lambdas that you need. And you can see here in this example that now we are retrieving an ARN from our parent layer for use in an application stack. So we have from user pool ARN here. One thing that's key here is, I'm not sure if I have a slide for this, is talking about the stack dependency management. And something to be thoughtful of is how your process management or change management will be across these layers. ensuring that you get updates, ensuring you don't have circular dependencies, that sort of thing. So as we implemented this solution, this was something that the customer loved, reduced a lot of CloudFormation files. It allowed them to stay compliant and move quickly. And they're very delighted by the solution that we built for them. Some of the takeaways from this solution, what we've learned are aspects can be really powerful to ensure various props or requirements that you need across your constructs. Definitely leverage those. I know other folks today have talked about CDK-nag, so I won't go into details. It's a really cool tool to catch non-compliance before deploying. We noticed this was a somewhat complex solution. I was really excited to hear from Rico's keynote talking about this exact problem space. So super exciting that the community and CDK at large are thinking about these problems. And I'm excited to see what we can come up with in the future to improve and simplify. So to sum up, your large enterprise challenges shouldn't stop you from using CDK to manage infrastructure. CDK is really powerful. You can build a lot of abstractions and reduce so much duplication and implement patterns that adhere to the well-architected framework. And consider custom pipelines if your needs require you to separate out job role responsibilities, various layers. They can really be helpful here. Thank you very much. I really appreciate your time. My DMs are open on Twitter if you'd like to chat with me. I'll also be taking questions in the CDK Slack. And if this problem space and some of these challenges are interesting to you, customer engineering is hiring. So if you're interested, I would love to hear from you. Thank you.
So thank you, Wes. This was great. And you are going to take questions in the Slack channel in the track free. So there you can find Wes. If you don't know how to get to the Slack channel, cdk.dev, and there you will find the link to get to the Slack channel. And with that, we are having a small break again of like 10 minutes or so. I will put the waiting time in the screen so you can go and relax a little bit, and then we come back to the last free talks of the day. And there are no more breaks, so do whatever you need to do in that break. And with that said, thank you, Wes, and thanks to interpreters. We are back in a moment. So we are back after a short break. I hope you got your cup of coffee. I did grab a little tea because we have 3 talks now in a row. And I forgot to add Kira to the chat. Sorry, Kira. But I don't say anything important. So now we have 2 speakers that are going to, Arun and Taylor, that are going to talk about leveraging CDK-nag for CDK application security and compliance. And we all love a little nagging. So I will bring them to the stream and I see you after the talk.
My name is Arun Donti, and I'm a software developer at Twitch. And today, with my good friend Taylor Ondrey, who is a consultant with AWS Professional Services, we'll be talking to you about CDK-nag and how you can use CDK-nag to enhance the security and compliance posture of your CDK applications. I'll be giving an overview of the features that CDK-nag has to offer, and Taylor is going to give you a pretty cool demo on how he uses CDK-nag to help his customers. All right, so let's start. What is CDK-nag? Well, CDK-nag is a construct that is also an interactive application security testing tool. Yes, that's a term. I didn't make that up. And it extends the CDK aspect system to help validate different resources that you've defined in your CDK application against a different variety of rule sets, which we call nag packs. Because CDK-nag is a construct that integrates natively in with your CDK applications, it can provide fast feedback for you when you synthesize or attempt to deploy your applications on things that you might be doing incorrectly according to those different rule packs. CDK-nag also has a reporting and suppression system that provides a mechanism for the development and security teams within organizations to work together to help identify and mitigate potential security and compliance issues. Maybe you have a workflow where security can choose what nag packs developers should apply to the applications, and then developers could use that feedback to quickly remediate those issues. Security can use the reports that CDK-nag generates to validate compliances. And furthermore, developers and security can work together to use those suppression systems to transparently document exceptions to rules that they've decided not to follow. I've thrown a lot of words at you, so let's show you with pictures what I mean. Okay, so let's talk about the validation system. So as you can see here, I've got a simple CDK application defined with one stack. And in that stack, I just have a Cognito user pool. Additionally, what I've done is I've imported the AWS Solutions Check nag pack from CDK-nag, and I've applied it using aspects to my application. So when I attempted to synthesize this application, you can see there's three things output into the console. In red, we've got errors, and in yellow, we've got a warning. So CDK-nag rules can either be warnings or errors. Both warnings and errors will be displayed in the console and in compliance reports, which I'll touch upon later, but only unsuppressed errors will prevent applications from deploying with the CDK deploy command. That's something to keep in mind. So let's look at these errors. So first one is AWS Solutions, which is the pack that we applied, cog1. That's a rule ID. So in this case, this rule is talking about, hey, your Cognito user pool doesn't have a password policy defined that meets these constraints. The warning, the second one, AWS Solutions cog2, is saying, according to this pack, you should probably have MFA enabled on your CDK application for the user pools. The third error is talking about a security mode that you should add to your Cognito user pool. So 2 errors and a warning. So what do we do now? Well, first off, you can attempt to remediate some of those errors. So for example, in this case, I decided, hey, I should probably follow a good password policy. So in my user pool, I've remediated that issue by putting that password policy in. Great. But maybe there are cases where you don't particularly want to follow a rule for whatever reason. So you can apply suppressions. We've got 2 types of suppressions. The first one is a stack level suppression, and the second one is a resource level suppression. Stack level suppressions apply to all resources within your CDK application. So in this case, I've decided to suppress the AWS Solutions cog2 rule, and I've provided a reason for that. The reason is required, but in this case, the reason was I wanted to demonstrate a stack level suppression. You as a developer might say something else as to why you're applying this suppression. So in this case, this will apply to all user pools within my stack. So if I decided to define more, the suppression would apply there as well. Resource suppressions are applied to individual resources within the stack. So my suppression for AWS Solutions Cog3 is only applied to this particular user pool, because that's what I chose to do. For the sake of transparency, we can see that all suppressions that get applied to the CloudFormation template that gets generated by the CDK application. Because at the end of the day, the CloudFormation template is a source of truth of what's getting deployed. So we can see here, the stack suppression got applied to the stack level metadata of my template, and the resource suppression got applied to that individual resource for the user pool. This also makes suppressions more portable. So for external users of your application, maybe they aren't using your CDK application directly. Maybe a security team wants to just review the template. This is there. This is transparent, and they can see exactly what's going on. For additional transparency, we've also got NAG reports that get generated by default. So you can see here that in this case, we've got the AWS Solutions check, which is the pack that is applied to the CDK-nag test stack, which is a stack that I have, and we've got a NAG report for it. You get a report for each pack that you apply for each stack. So if you had 2 stacks with AWS Solutions, you'd get 2 AWS Solutions reports. If you had other packs as well, you'd get reports for each of those stacks as well. So what's in the report? So in this report, you can see in my stack, I had 1 resource defined that you could see here, and there were 3 relevant rules for that resource. So we can see the output of those relevant rules for that resource. We can see that a rule was compliant. We can see that 2 were suppressed as we suppressed. And if we actually had lingering non-compliant rules, that would show up here as well. For suppressed rules, you can see additional information on the reason that was added for the suppression, for demonstrator stack suppression, demonstrator resource suppression, and cutoff, we have more info here. That could be the rule level, so warning or error according to the pack, and then additional rule information. So AWS Solutions.cog1 doesn't probably mean a lot of things to most people, but it provides information that we saw in the console about like, hey, this rule is specifically for that password policy. The other 2 rules are for those other things. So here is another way for security teams to review what's happening in your application, and it's a good overview of like all the suppressions and stuff. And since this is the CSV, you can import this into the application of your choosing and analyze it that way. Okay, so let's talk about NAG packs. In my demo, or in my examples, I'd only applied the AWS Solutions pack. Out of the box, CDK-nag has 5 different packs. The AWS Solutions pack is based on a set of rules that the AWS Solutions architect teams and AWS professional services teams follow for releasing content to customers. The other packs, HIPAA Security, NIST 853, both revisions, and the PCI DSS packs, are based off the AWS Config Conformance Pack sample templates that AWS has released to help customers meet those compliances. So you can use as many packs as you want on an application to vet your CDK applications. One thing I want to point out before I hand it off to Taylor is that CDK-nag also has the ability for you to build your own NAG packs. So you can use rules that are already defined in CDK-nag in conjunction with the rules that you define to develop those NAG packs and distribute those to your developers. I'm not going to go over that in this lightning talk, but if you're more curious about developing and distributing your own packs, check out the developer documentation in the CDK-nag GitHub repository, and you'll be able to see how to do that. Now, I'm going to hand it off to Taylor to talk about a real-life use case and to give a demo of CDK-nag.
Hi, I'm Taylor Ondrey, Senior Professional Services Consultant at AWS, supporting our customers in the worldwide public sector. The worldwide public sector consists of thousands of customers across government, education, nonprofits, and healthcare. Now, there are a multitude of security and compliance frameworks to keep in mind when building infrastructure for public sector customers. Here are just a few for the Americas. Adhering to these compliance frameworks is often a non-negotiable for these customers. However, building infrastructure for customers with these compliance requirements can bring a lot of challenges for builders. Compliance with these frameworks often isn't evaluated until after much of the development work has already been done, which can result in significant rework or refactoring. Many times, the language that compliance rules are written in are difficult for builders to translate into the code that they're writing. And on top of that, builders are often given spreadsheets with dozens or hundreds of security compliance checks and asked, "Can you fill this out?" Resulting in hours and hours of time to parse through those checks, to see if they're even relevant to the architecture they built, and addressing the compliance rules that do apply. Using CDK-nag in our CDK infrastructure helps us address many of these challenges. To show how, let's dive into a demo. So here I am in a newly cloned repo that's totally empty, and I'm going to start a new CDK application in Python. Great, now let's open up VS Code. Now I'll get my virtual environment and all my Python dependencies installed. Great, so here my application is all ready to get started. I'm going to create a few simple resources. First, let me remove some boilerplate. Now I'm going to create a simple VPC and an RDS instance. Great, simple enough. Let's just make sure this can synth okay. Great, everything looks okay, but we want to make sure that we are building security into this process. So we can use CDK-nag to do that. Let's get started with that. I'm going to open up app.py and clean up a few things. And let's get the CDK-nag installed. Now that CDK-nag is installed, let's import the nag pack we want to use here. So we have a couple options to choose from, some of the built-in packs that come with CDK-nag. For this example, we're going to assume our customer wants the NIST 853 Rev4 checks. So I'm going to import that, and we'll add these checks to our application. Great, so this is added. Now we're going to try and synthesize the application. Here we go. We have some errors. If we scroll up, we can see some errors and warnings, and we can see some pretty good detail about which specific resource in our CDK application is violating specific rules. So here's an example where VPC flow logs are not enabled on this VPC. Same with on the RDS instance on MyDB, the enhanced monitoring is not enabled. Let's go and try and address some of these. Okay, I've added some of these. Let's try and synthesize again. So we still have a few errors, including instance deletion protection. So I'm going to go ahead and make sure that I include that as well. One more time. Okay, remove that last one, and we're left with a few of them. So let's take a quick look. So these first two errors, we are getting an alert for IAM no inline policy, as well as on the flow logs log group, it wants those CloudWatch logs encrypted. So there are certain times where maybe the rule doesn't necessarily make sense, or you have a reason that you're okay with doing that and you want to put that in there. I'm going to add a couple suppressions for these remaining errors. The first thing I'll do is import a few of the NAGPAC suppression modules. And now I'm going to suppress some of these rules. So here I can give the rule ID that I'm going to suppress as well as the reason. Now I'm going to add one more rule to the database. But before I do, I want to make sure that I apply these to child resources. The reason this is a VPC has an L2 construct, and there are a lot of other resources that go underneath it. So for example, the inline policy on the role for exporting to CloudWatch logs is one of those policies, as well as the log group on here. So since we're applying this to the children, we can look at any of the children underneath this VPC and apply these suppression rules to it. Now let's add to the database. Great. Now, the moment of truth, let's try and synthesize one more time. So now that this is successfully synthesized, one more thing that the CDK-nag gives you is if you look inside your CDK out, which is where your resource, your synthesized asset, your compiled assets, or your synthesized CloudFormation templates are, you'll also find a CSV file for every stack in your CDK application. Opening this up, you'll see a CSV report here. I'm going to make this look a little nicer. So as you can see, you have a nicely formatted report that shows which resource in your CDK application was reviewed, what rule was examined for it, and whether or not it's compliant or non-compliant. And if it's suppressed, what was the reason that it was suppressed for? So let's move back to the compliant project stack. Something you might notice here is that while this makes sense in a production environment and certainly complies with the CDK-nag rules, sometimes it doesn't make sense in non-production environments. Things like always retaining a RDS instance or making it multi-AZ might not make sense for a dev environment. We can conditionally add these in. Let's do that now. So I've suppressed some of these rules, but what you might realize already is if we do a synth, sure enough, we have CDK-nag errors preventing us from synthesizing and therefore deploying. In this case, we're going to conditionally suppress these rules if we're not in a production environment. Let's do that now. Now that we have these all suppressed, let's try and synthesize one more time. Looks like I had a little typo in here. We fix that and synthesize again. Great. So now, conditionally based on the environment we're in, we are either ensuring that all of our NAGPAC rules are being enforced or appropriately suppressing, or in non-production environments, we're suppressing the properties that we're okay with for cost savings purposes.
Thanks for the demo, Taylor. I wanted to leave this presentation off with a note. Aspects and by extension CDK-nag are great mechanisms for fast feedback. However, you shouldn't be using them as the sole source for enforcing compliance. Developers could remove the aspects, modify resources after the fact with other aspects, or property overrides. You have other tools that can help there too. Things like AWS CloudFormation hooks can help determine at deploy time whether resources meet the requirements that you have. You also have things like AWS config rules, for when resources have been deployed, whether they remain compliant to your specifications. Those are some things to keep in mind. But with that, thanks for watching. Thanks, Taylor, for that demo. And I hope you have a good rest of your day. Take care.
And we are back. And this is the last talk of the day. I just got informed that the last talk that was added got removed. So now we have the last talk for the track 3. And after this talk ends, don't go anywhere. Well, go to track 1. That's the place you need to go. The links are in the description box. And there will be a quiz after this talk ends. So don't go anywhere right now, because now we have our last speaker, that is Joel Hamilton. How are you doing?
Yeah, good, thanks. Happy to be here, Marcia.
I'm super excited to have you, and you're the last one for my track, so thank you, and let it shine.
Awesome, thanks.
Going to talk about full stack types with CDK. One type
correct.
to rule them all. That sounds interesting.
Awesome, yeah, looking forward to it. Thanks so much. I do have some slides. It should be.
I will put them on for you,
awesome.
And I will disappear.
There we go. Let me just make sure that I can move them. Yeah, cool. Thanks so much. Yeah, thanks very much. Cool. Hello, everyone. It's good to be here. Today I'm going to be talking to you about full stack types with CDK. One type to rule them all. Thought it was a nice, fun, catchy title. Thanks so much, Marsha, for introducing me. So quick little introduction to myself. So my name is Joel Hamilton. I'm a cloud engineer at Alios. I am also an organizer of the Serverless London meetup. And yeah, I recently gave a talk there. In fact, there will be a recording of that soon. So if you do want to check it out, then please do. I'm also a contributor to the SLS Test Tools, which is an open source testing framework for serverless infrastructure, which allows you to test on the real infrastructure. And also a contributor to the Serverless Transformation blog, so I highly recommend you check that out as well. So, quick touch on what is serverless, because I'm a serverless engineer. To me, what it basically means is not needing to think about servers ever. Sort of all aspects of server management, like scaling, security, managing capacity, things like that are basically outsourced to the cloud provider. To me, serverless also means close to infinite scalability, not actually infinite, but pretty much so. And also you pay for what you use, so no idle costs. You'll never really be paying for, having something running on a server that no one's actually using. So yeah, I'm a big fan of serverless. So yeah, what are some of the main AWS services? I'm sure most of you know most of these, but yeah, some of the main ones that I've used are API Gateway for routing HTTP requests, AWS Lambda, which is function as a service, DynamoDB, which is for storing data in a NoSQL database, Step Functions, which is one of my personal favorite services for configuring workflows, and SQS, which is simple queuing service. So what is AWS CDK? Basically, I'm sure most of you know this, considering I'm the last talk of the day. So you've seen a whole bunch of talks today about CDK. But basically, it's a framework for defining your AWS infrastructure as code and using familiar programming languages. So I quite like to use TypeScript. Here's an example of defining a DynamoDB table in CDK using TypeScript. And basically, there it is. Got all the same fields that you'd have in something like a CloudFormation template, but it's in code. So there's the billing mode, the PK, the SK, and the table name. And it looks pretty much just like any other piece of TypeScript code. As I said, I quite like using a typed language. Gives you things like autocomplete and that sort of thing. But there's a whole lot of benefits to using a typed language, some of which I'm going to dive into right now. The main overarching theme is improved code consistency. So I think there's a lot of benefits to being able to use the same language across all layers of the stack. Even minor things like the same coding standards, so like code style, linting, a lot of places have like requirements on like having the order of import to be the same in every file. Being able to use the same language across all layers of the stack gives you that benefit. There's also things like being able to just have consistent code readability across all layers of the stack, as well as rapid code navigation, being able to click on a type and see, okay, cool, this type consists of fields X, Y, and Z. I now know that if I'm creating an instance of the type, I need to make sure I have fields X, Y, and Z. Also increased IDE support, like especially if you're using like Visual Studio Code or something, you create an instance of a type, you put the variable name, you say dot, and all of a sudden you put a dot in, all of a sudden you can see all the fields which make up that type. It's highly useful. And yeah, the final point is it's also a potential use case for full stack types, which is the topic I'm talking to you about today. So what are full stack types? So full stack types is essentially sharing types between all layers of the stack. And by using CDK, especially using CDK with TypeScript specifically, it opens up the possibility of including those types in the IAC as well, meaning it's the entire stack. It's the front end, which could be something like a React or a Vue app, a back end, which could be, in this case, like a Node.js or Node TypeScript API, and the IAC, which would be using CDK, also using TypeScript. So why would we want to do this? So, I mean, I just gave you a whole bunch of reasons why type languages are good in general. So why not, pretty much? But also, other than that, there's also the fact that you'd have reduced code duplication. So you're not defining the same type or basically the same type in a whole bunch of different places. There's also type consistency, no type mismatches. So, if you needed to define something like a user type with a certain field, something like a name, a surname, an ID, in more than one place, there's always a chance that there's a mismatch in one place it has an additional field which the other place doesn't have, or something like that. I also think in general, using a type language allows you to debug much faster. There's also a reduction of bugs. And the main thing is also you can catch bugs earlier. You can catch errors earlier by using things like autocomplete and also built-in type checking when linting. So yeah, so how might we do this? How might we use types across all layers of the stack? So if you're using a monolith, it's pretty easy. You can sort of just export the interface for each type and import them in the front-end files, and there you go. It's a bit tougher when you're using more of a distributed system, something like a microservices architecture. An idea I've had is you could initialize a repo for a types package and actually publish it via NPM privately, and then you just import it into every layer of your stack, and there you go. You can use the same shared types. So yeah, I do have a simple example to sort of illustrate the idea. So yeah, you can there's a construct in CDK called the gateway response construct, and what a gateway response is, it basically allows you to create a custom response for unsuccessful API calls. So if you have a 400 or 500 response code, the schema of gateway response construct is as follows basically. So it's got like, you pass in your REST API, the response type, which could be something like access denied or something like that. You then also pass in the headers, which is actually what I'm going to focus on here. You pass in your status code and your mapping templates. And so here's a typical example of a gateway response declaration in CDK. As you can see, it's got all the fields I just mentioned. For response headers, I've passed in just a message saying the server returned a 400, bad request, and a hint saying double check that all the required fields are present. I know that in the real world, API response headers contain a lot more metadata than just a message and a hint. But because everyone knows what they are, they're a pretty simple example for just illustrating the idea of how we could use types in the IAC and also elsewhere in our app. So if we wanted to type our headers in, as is in the previous example with the message and the hint, we could have a type called headers type. We have the message, which is a string, the hint, which is a string. We then create an object called headers, which is an instance of the headers type, and pass in the headers object into our gateway response construct. So here it is, the exact same construct as before, but now we're passing in our headers object instead. So if we publish the API, then we're good to go. And essentially, we can use that elsewhere in our app now. If we then, like in the front end, we could import the headers type from our shared library, which is maybe published via an NPM package, as I said, or just import it if you're using a monolith. You can then make a call to the API, say you get a 400 error, you can receive the response, pass it, and then you can just cast the response headers to our headers type. And all of a sudden, you get all the benefits of using a typed object, right? You can either cast it using as, or you can cast it by reassigning it and defining it as declaring it as a headers type object. And all of a sudden, you get autocomplete and all those benefits I mentioned earlier. I'll give you another example here, although this example is slightly higher level. Don't really go into as much detail, but bear with me because it's a bit convoluted. So if you're using step functions, quick overview of step functions. Basically, they're state machines. There's 7 different kinds of states. This example focuses on past states. On the right, I've just pasted an example of a step function I've used in the past. So, I mean, this one is very simple. It basically hits all the APIs directly, doesn't use Lambda. It creates a Cognito user pool. It then creates a user pool domain for the hosted login for your user pool. It then has a DynamoDB put item operation, and then publishes something to SNS, could be like sending an email out saying your user pool is created or something. But yeah, so this example focuses on parse states. I'm not going to go through all the different kinds of states, but basically what a parse state is used for is it's used for injecting fixed data into our state machines. So on the following slide, I have an example of JSON, the JSON configuration of a step function which uses a parse state. In fact, this is just the JSON configuration of a parse state itself. And as you can see here, that's what the parse state configuration looks like. The result object is the data we're injecting. And then here, if the input is georef of home, then essentially the output will just be the data we're injecting as well as the input. So how would we do this in CDK? As you can see, it looks a lot cleaner because it's just in TypeScript, so obviously it's extremely readable. As you can see here, we're defining our parse state. We're passing in the result. Here we have an object with a field hello, whose value is world. This code example is taken from the AWS CDK docs. And let's look at an example now of how we can maybe involve some types here. So this is a simple step function containing literally just a parse state. The data we're injecting in through the parse state in this case is an object with the field name, whose value is server, and the field surname, whose value is less, serverless. And yeah, we just inject that data directly through the parse state. How could we do this using types? So we could have an interface called person, because I think name and surname, person seems like an appropriate name. We can then create an instance of the person object called serverless person. We pass them the name server, the surname less, and then we create our construct, our parse state construct with the exact same fields as before, but now we're passing in the serverless person object as opposed to passing in the fields directly. And there we create our step function at the bottom. What happens next? How could this type be useful anywhere else? So consider the following example. There we have our parse state in the step function. The next state is a lambda. Say we then import the type. We then marshal the object. So basically prepare it for insertion into a DynamoDB table. We then put the item into the Dynamo table and the step function finishes. Then in the front end, we could make an API call to get the person's data. So let's say our person type also had an ID or something like that. You can hit a lambda using API gateway. The lambda can then perform the get item request on the DynamoDB table. The DynamoDB table returns it. In the lambda, we could import the type as before, the person type, and cast the result of get item to our person type. And there we have the object of the correct type in the backend. The same thing can happen in the front end. If we return the data as the response of the API call, we can import the type and cast it. And now in every single layer of the stack, we're using the exact same person type. So type consistency throughout, and all the benefits of using types in general, like autocomplete and early and catching errors early, and all the other benefits I mentioned earlier. So I figured it would be a good idea to mention testing here. So a lot of this talk is focused sort of around what the idea of a fully typed world, an entire repository, or an entire project where everything's using the same types. And it kind of got me thinking, what is in the world of fully typed projects, what does that mean for testing our AWS infrastructure and cloud native applications in general? So I always like to start off with why test, because I'm a big fan of testing. I think the general argument is it's pretty clear: increased robustness, increased software quality, less bugs. And also, I think a commonly forgotten one is an improved developer experience. Because if you're using something like TDD, test-driven development, it provides constant validation that your code works. I think it's very empowering for a developer to, as they write code, know that it's correct and it's working correctly. This is just a little diagram that we created, which essentially shows the 3 different types of testing: unit tests, integration tests, and end-to-end tests. And it's a nice visual because it describes sort of which ones you'd run first, and also how long they take to run and the cost of running them, etc. So how do we normally test our AWS infrastructure? So I'm a big fan of using SLS test tools, which is the open source framework I mentioned earlier for testing serverless infrastructure. What I quite like about it is it allows you to test on the real infrastructure as opposed to just mocking. Because obviously mocks need to be updated and things like that. And I think if you have the opportunity to test on the real infrastructure, it's always a good idea to do so. Also, almost just a little quick aside, when I say testing our AWS infrastructure, I mean testing that we've configured our AWS infrastructure correctly using CDK. I don't mean testing that the AWS infrastructure does what it says it does, because that's a question I've had in the past. I just mean testing that we've used the AWS infrastructure correctly, essentially. So how could we test a CDK-defined step function using SLS test tools normally? Normally, we are able to do things like asserting that the state machine has the correct execution status. So this assertion here allows you to pass in the state machine name and essentially assert that the latest execution of that state machine has the correct status, which would be something like succeeded or failed. At the bottom, there's an example of asserting that a step function called test, add, and double has had its most recent execution completed with the status succeeded. Note, because it currently looks at the most recent execution, these tests can't be run in parallel, but we're currently refactoring that, in fact. So yeah, another kind of assertion you could normally make on step functions would be something like asserting that the state machine produces the correct output. And this is quite an interesting one here, and there's an opportunity to improve this somehow by using typed objects. So what this one does is it allows you to, again, it takes in the state machine name, and it's called .toMatch state machine output, and you pass in your expected output object and asserts that the state machine's most recent execution has the correct output. But how could this change in the fully typed world? If you know for a fact that the output should be of a specific type, what it allows you to do is it allows you to say, I expect, you could do something like expect that the object has an output matching type and pass in the type. I mean, this is just an idea, but for example, sometimes we don't know what the exact output would be, but sometimes you know exactly what kind of type it should be able to match. And this is a good example of what typing a project allows us to do. Another thing I wanted to touch on regarding testing is how could you involve types when testing CDK-defined DynamoDB tables? So normally in testing DynamoDB, you could say you could pass in PK, pass in an SK, and assert that the object exists with the given keys exists in the Dynamo table. But perhaps we could type this, right? You could create something like a keys type, have a PK, an SK, create an instance of it in the bottom left there called keys, pass in the value, test PK, test SK. And yeah, what's pretty cool is what this allows you to do is if you're creating an instance of the type and say using the same table elsewhere, but you're running a lot of tests, this allows you to catch errors earlier, right? Because here in the bottom right, what I've done is I just created another instance, but I tried to set the SK to 1, 2, 3, 4, 5. And instead of running the tests, or even worse, deploying and having the test running in CI, and all of a sudden catching it then, here at coding time, essentially, or before compile time, you're able to determine that the SK was of the wrong type, which I think is pretty powerful. So yeah, so I think the two key takeaways for testing fully typed projects are that by typing the inputs of our assertions, we can catch type errors at compile time instead of only when the test is run. And also, we can assert that objects of the correct type, making our code just even that little bit more robust and less error prone. Conclusions, looking to the future, I think, admittedly, yeah, the use cases currently for using the types in IAC are maybe a bit convoluted, maybe a bit niche, and some of them require a bit of overhead, but I think the motivation is clear. I think CDK in particular, it empowers developers to maintain consistency across all layers of the stack by using those familiar type languages which we all know for IAC. And also, I think when it comes to typing items in the IAC, think of all the possibilities. You could have things like typed event schemas, typed database schemas. Like, I'm aware that code and infrastructure aren't the same thing, but I think that line's being blurred a lot. And I think as that line gets blurred further, there's going to be a lot of other programming primitives that will empower developers to blur that line further and to essentially allow their code and their infrastructure to become one. And yeah, that's pretty much all the main content. Do please, if you have any questions, do reach out to me on LinkedIn, do reach out to me on Twitter. I'm sure we're all rushing to get to the quiz on track 1, but thanks for sticking with me through this talk. I hope you all enjoyed it. Do check me out on Medium and reach out and connect because I love growing my cloud computing network. And yeah, just very happy to be here. Thanks so much.
Thank you very much, Joel. Please contact Joel afterwards. All the links are in the screen. And also he is in the Slack channel. So you can go and find him. No hurry. The quiz is in a while. So people will go there. We'll get on time. So no need to panic. But yeah, so go to the Slack channel. I put the link to join the Slack channel if you haven't in the chat of the YouTube. So you can click there and join and then find all the speakers that have been through the day and also Joel in there. And thank you very much, Joel. It was a great talk. I really like this library that you show us. I will explore it. It sounds
fantastic.
Cool.
Yes. Yeah, thanks so much for having me, Marsha.
No problem. And I will get you out from stream and say bye-bye.
Great. Cheers. Bye.
Bye. So thank you everybody for being in Track 3 today. I hope you enjoy the talks and don't leave the event yet. We have Track 1 running and Track 2. And in Track 1, we have a quiz. And it's starting in a few minutes. So there you will be able to get AWS credits if you answer correctly. So the link for the Track 1, you will find it in the description box of this video, and I will put it in the screen as soon as I finish speaking. And with that said, thank you very much. I hope you enjoy this track and enjoy the rest of the event. Thank you to the interpreters, Wes and Kiera, and I see you around. Bye-bye.